Welcome to jobskillshare.org. This is your fourth week session on routing. Now, this video is designed for our members who are taking our junior network training program with us. And we have given this to you in your materials. So you are actually going to go ahead and finish this material before you take our live training. So right now we highly recommend that you go over all of these videos right here and then actually configure router and work on all of these labs before you see your instructor or you go over this live session. Now, yes, you may, if you're new to this program and you're not taking our training, then yes, you can definitely go through our this video trying to learn what the instructor is presenting on top of routing. But for some people who are new to this program, I just want to remind them that of course you're going to be missing a lot of things that we assume from our members already. So that's why in our trainings we're only talking to our members in those live sessions. So if you miss something, then maybe you have to do your own research to cover that. But for our members, please go over your lab, your sessions in the test out, try to finish that. The reason for that is that when you do it yourself, you will have a lot of questions. And then when you hear the trainer in your live session, or you, let's say you missed your live session that day and you hear this video now and you go over and you do these labs, many questions will come with your training inside test out. So then you will have better questions, you will have more questions, you may have some kind of lab question, and then you can present that into your Discord where you can collaborate with your teacher. So I hope that you are going to learn a lot from this session for routing. And without routing, of course, there's no way you will be able to even do anything, because routing is the main the main networking that happens is on routing, and then after that you have other communication going on, and configuration on switch level, and then you have endpoints or servers. And this is going to help you a lot in your future in advanced positions, because when it comes to advanced setups, advanced infrastructure, you must need to know how routing works, not on just an infrastructure on-premises level, but on a cloud level as well. You need to know routing, and that's how you're going to move forward with your career. So I hope you will take this seriously. It is going to be a lot of theory, a lot of understanding, because that's what we are covering in Network Plus. In Network Plus, we try to give you a lot of hands-on as well, but of course we cannot go to extreme details like CCNA, which is going to be your next course after this. Thank you for watching this.
So the agenda is same. We will go through the concepts of these one by one, and then if you have any questions or doubts, you can ask. And then I have added two major labs in it. One is depend on the concept that we have gone through already in the earlier modules, like switching, VLANs, trunk. So I thought I should add that as well, because it will add value into this module, because on the basis of switching, on top of that, we are going to create our routings. Okay. And we are familiar that if your physical layer is dead, it means nothing will work above. Similarly, layer 2, it will not work, layer 3 will not work. So it is dependable of everything. So physical layer depending on layer 2 depending on layer 3, and vice versa, and so on and so on. So that is the reason I added the switching concepts as well, and it will be like the brush up as well for you. And I also added some new concepts, and you will see. If you can give me the answer, what is router used for?
The router is used for the communication between two different subnet or network.
Very fine, very fine. Good. Any idea about routing versus routed protocols?
The routing protocol gonna be the protocol that we use, that the router used to sending the packet between them.
That's fine. How about routing?
The routed protocol will be the other protocol that is transported within the packet.
That's fine. Okay, no problem. I will just skip this for time being. Why? I will show you why. Okay, difference between AD and matrix. I think you went through this thing, yeah? AD, administrative distance, and matrix. Any idea?
Yes. I know that in matrix, they were talking about bandwidth or cost of the path.
Okay, that's fine.
And the administrative distance will be the fixed distance for the, depending of the routing protocol used.
It's a kind of believability. We will discuss. No problem. What it stands for, I just need to know the abbreviation. That's it.
Open. Oh, I forgot.
Okay, no problem. Open shortest and then path first.
Okay.
It's a routing protocol, just like RIP or EIGRP or something like that.
Yeah.
Any idea what is link state in routing protocol? This term is known as what? Link state.
Is the matrix that OSPF use? No.
What for?
To communicate the information.
Exactly. You're right. Okay, your idea is almost there. So OSPF is a link state routing protocol. And there basically, if I just can give you a live overview, we have two kind of routing protocols. One is known as, one is distance vector. Another one is link state. Distance vector is like, you know, they are like blind. Okay, if for example, we have routers here, we have multiple routers connected. Just a minute, I will give you. When I can take these routers to remind me that. Okay, they are all interconnected with each other. At this time, this router, and what is distance vector, whatever they are telling this router, for example, there is one network, there is one network, there is one network, and there is one network. So whatever the information these routers are providing this router, okay, so he's believing on these routers. So whatever the information, like 172 network, we have 192 network, let's suppose this is like 10 network, and this is, let's say, 11 network, some IPs, you know, here some subnet is there, and it is learning these information on this router. Okay, so this router has no idea what is happening behind the scene. So whatever the information this router is learning from these connected routers directly, it will believe. This is known as distance vector. On the other hand, the link state is this router has information about everything behind the scene as well. For example, if I give you, let's say, if we add another router here, another router here, and this one is connected this one there, this one is connected this one there. Now this router is not only having information who is connected with me, but also he will also familiar with what is connected with this router, and this router is connected with what other routers. Okay, so this thing known as the link state, you can just remember it, just link by link. This router has the complete idea about everything in the topology. Whereas in distance vector, this router just know that I'm connected to this router who is giving me information about the other, for example, one subnet is here. That's it. So this router knows this information that is here I am reachable through this router. Okay, this is distance vector. On other hand, link state, this router know about this route inside routing table from this. He has complete path. So this is the difference between distance vector versus link state. What FHRP stand for?
Right now, I don't remember.
Okay, first hop redundancy in switching environment or even routing environment. When we need redundancy. Okay, if I give you example very quickly here. If I have two routers here, and this is our internet ISP router. This is connected with this is connected with this, and this one is this, and this one is. Let's suppose we have one computer here. He wants to communicate with the ISP. So the chances are maybe this router is down. How would this router know that this router is down? If he's not using routing protocols, then they will use kind of some protocols. I think you will learn in this same module in a subsequent videos that it will use like kind of HSRP, VRRP, and GLBP. Any idea about these protocols, Christian?
Yes, I know that. I don't know what it stands for, but I know that it's used in case of redundancy.
Yes, exactly. Okay, so this is the reason they use these protocols. If this one is down, automatically the flow will go through this router. This is as a backup, and this is like a master. This is slave, active, or active. Sometimes active is used in GLBP. Active and passive is used in HSRP, and master slave is used. You will learn soon. What is inverse R or inverse mask? Sorry, not inverse R.
They call it wildcard. So it's the inverse of the subnet mask.
Exactly. Whatever the subnet mask is, if you do it reverse, it is called inverse mask. And the use case of these are, it is used in OSPF as well as in ASA firewalls, and also in a access control list, ACLs. When we will learn about ACL, you will see. Okay, so this is inverse mask. This is the areas where inverse mask is being used. What is this thing used for? This 000/0.
It's used for the default route.
Okay, exactly, 100% right. What means? If you can just elaborate more, means what is the reason?
So when you try to look at the route, you type the command show IP route in a router. If you see that line, that means if there is an address, I mean, if there is a path which is not specified on the router,
okay, that's fine.
The address is going to use that.
You're very right. Means if a router not able to find some specific route in its routing table, okay, the final thing it is gonna do, it will send to this. This could be gateway, your default gateway. Default route. This is known as default route. Default route. Why do we use NAT? And I have already answered that in Discord as well.
We use NAT to translate the address in the LAN to the registered IP address public.
Exactly. You're right. So this one, you will make the assignment. Okay, routing versus routing protocols, and just take a snapshot and just share with us on our Discord, just like you did in a stack-wise versus chassis. That was very good, by the way, this time.
Okay, thank you.
So this is just a reminder to let you know that this is your Network Pro module. As you can see, what you have covered or what you are covering right now, this is routing basics, routing protocols, network address translation, and some troubleshooting. But if you take a look of CCNA module, it's all about these things, everything in great detail and nitty-gritty detail about everything. IPv4 routing, talk about static routing, dynamic routing, IPv4 troubleshooting, network communication. Then this area is just talking about OSPF, which is a link state protocol. And this is the EIGRP, which is known as hybrid protocol. Hybrid. And hybrid mean EIGRP has some kind of distance vector characteristics as well as link state. And OSPF, by the way, is being used in ISP service provider also. Why? Because this is not this is a standard protocol. I mean, it is not owned by the Cisco. EIGRP is, you know, owned by Cisco. That is the reason service providers, they don't use EIGRP, because they have to use Juniper routers and, you know, multi-vendor routers. That is the reason.
And it's kind of important that if you look at it, Network Pro module that you guys are taking right now, well, the reason this is basics, and we're going to go into a lot of this understanding and theory that's why we don't want to start with the CCNA, because if you look at CCNA on the right side, so much information needs to be covered in these modules. And if somebody's new to this stuff, it's just too much for someone. But if you look at it, if you want to prepare yourself and you really want to learn this stuff, then this is the time to learn the basics correctly. So make sure you go back to your week 4 and finish that in testout.com, do the labs, and ask as many questions you have in terms of theory and the basics, because that's going to be important when you start seeing Kamran in CCNA. He's going to go to in a little more deeper theory and deeper labs. So this is where we are going to then not come back to the basics again.
Yeah, exactly.
That's why we added these two slides together, just to show you the differences between these two courses. It's pretty clear that one is basics and the other one is pretty detailed.
Yeah. So likewise, we discussed about the Cisco switches, the physical, the look of those switches. So we're going to discuss about the routers, how routers look like. So this is the front and this is the back. As you can see, nothing going on. Unlike in the switches have multiple modules, because the switch is all about switching. Router has to do just the best part. So that's why it has nothing to do with those multiple ports there. So this is the front, and as you can see, we have power over Ethernet. Sorry. We have power over Ethernet as well, and we discussed in our last module that why we need power over Ethernet. And sometimes if some device which is capable of power over Ethernet, let's say one IP phone or some CAM or something like that. Okay, so we have this functionality. These are active links, and this is for the system itself. And other than that, we have, as you can see, input power connection here. And by the way, we do not have any RPC here, which is redundant power supplies. Let's suppose if we have the same thing here as well, then this thing is known as, this router is capable of RPC, which is not. Then this, as opposed to the switches, as you can see, we have this switch. You can switch on and off. Then other than that, we have these two, because service providers use these kind of routers. That's why this is known as CE01, which is known as customer edge. And this is for Ethernet. And I told you yellow, wherever the yellow label is there, it means it is belonging to the Ethernet. And where we have this baby blue color, it's like, as you can see, it is a serial console port. And we are familiar that why we need console ports. Okay, then we have flash. We remember if we talked about the memory concept there, we talked of the flash and the USB as well. Now it is USB capable as well. If you want, you can plug in the USB as well. Then we have these things. These things known as modules. And what they do, you can purchase from Cisco supplier the same modules. These are known as big cards. 2-wick, basically 2-wick for the wide area interfaces. Okay, these are the serial ports. So this is old technology, and these are the new technology, by the way, this one. So these are the old technology, but still I added, so you have better idea. Still some routers, they have these kind of interfaces. So this is like module. You can just unscrew these things and it will be come out, and just slide it inside it. So when you will switch on this router, you will see you will have these serial ports enabled on the router iOS. Okay, so since we are going to hit router, so this is, I'm just giving you small office, home office, how it will be look like. This is your typical home home topology. This is your service provider. Then this is your router. Okay. When we talk about the routers, it has just a minute. I can see some sounds in my computer. I want to stop it. Just a minute.
Yeah, sure. Take it down.
Okay, that's fine. This is a small office, home office network, in which this is a typical network for your home. As you can see, this is your access point. This is just like a router. Then you have, let's say this printer is connected with the router. Then you have multiple computers, laptops, PlayStations, your iPod, iPad, or even these servers even connected with a small network. So we are familiar that why we need network, so we can communicate with these devices. Okay, so this is kind of small office, home office network, and it could consist of like 10 to 15 hosts, basically. Usually this is considered to be the SOHO, small office, home office network. If we move further, this is, you can consider it like medium size enterprise network, medium size network. Okay, where we can have like 50 to 80, or could be even 100 hosts connected. And what is going on in this network? As you can see, this is same. We have ISP, or the cloud, or the internet, which is connected with the firewall. So firewall will be your segregation point between your outside world and your inside world. Then this firewall will be connected with the router. and we know that what router will do, whatever the these guys will try to access the internet, or even if they want to reach this data center, the all queries will go through this router. The router will process and will have idea whether I need to send this to the internet, or do I need to send it to the data center. Then we have multiple switches in the same network, and this is segregated with this router. If I can use a different color. So this is our one network, and this is our second network. So this is a segregation point. But if this user wants to communicate with this user or the host, it has to go through this router, and the router will decide whether this network is available on my interface or no. If available, it will route the packet through its interface. So this is like the typical medium size companies having these kind of network topologies. So if I move further, as you can see, it comprises of end host. These are known as end host. So I'm using these technical vocabulary, okay? End host, when they are talking about end host, these are not just these hosts. Maybe they are talking about these wireless LAN controllers. Maybe they are talking about these voice over IP phones. So these are end hosts. Then we have switches. These are the switches. Multi-layer switches. Sometimes this is switch as well, and then this is capable of switching and as well as routing. So this thing is known as multi-layer switching. But if this router does not have capability of switching, then this is known as routers. Then we have wireless access points, like these are wireless access points, and wireless LAN controllers. Firewall, IPS, IDS, I discuss here, and next generation firewalls. So this is like the advanced mode of firewalls, is next generation firewalls. And when we will hit this security concepts, I will talk about next generation firewalls as well. So since we are here and we are proceeding for IP routing, we should have a better idea the network architecture, how it looks like. So this is known as 3-tier architecture. This is known as 2-tier architecture. 3-tier architecture, this has been obsolete now, pretty much. Why? Because first of all, get the idea what is 3-tier architecture. We have access layer, distribution layer, and the core layer. Access layer is where we will have our end host or end machines, the computers, voice over IP, and these all. Then we have distribution layer. So basically, if this host wants to communicate this one, it will go through these distribution layers. Then let's suppose if we have the same architecture, let's say this is a building one. Building, let's make it building number A. And just copy and paste it here. We have building B. So what if this host wants to communicate with this host? So that is the reason we have core layers here. You will have another core layers here, which will be like interconnected like this way.
So Kamran, I think let me take you back in this, because if let's say, and this is coming from someone who's new to network. Okay. When we talk about architecture, before this, there's this gray area for a lot of new people, and even me myself had the struggle in the beginning. A lot of people want to know how, like in a real company, where does it start? So if an ISP like how do they get that first connection from where? So let's say it's an ISP, some name, let's say Comcast, right?
Okay.
So Comcast gives you the router, the ISP router.
Yeah.
And after that, how does it work? Like in your experience, how does it start from that point? Because this is where a lot of new people are like, okay, where does it start? So if the ISP starts it, so who gets that public IP address? Like who this company buy it, and then who kind of break it down and then come to the architecture? I think that would be a little bit better way for them to understand. Because right now, I feel like people are going to be confused when they straight jump to the architecture. They may not understand like where does it start actually. So maybe if you can just explain the whole flow.
Okay, that's why, okay, no problem. That is the reason I went through these simple small office first.
Let's go to the first slide. I want to ask you the question on
This
the
one?
routers. No, go back to the router question slide. There you go.
Okay.
So let's start with that CE modules right there, where it's 0-1 link and 0-0.
Okay.
This is where a lot of people will have this question that, okay, we say that this is a ISP providers or someone who's going to give you that connection, right?
Okay.
Because that's where the new models are actually where we are using that. We're not using the serial on the left side. And that's true. So in a lot of companies, you will get this router. In my example, let's say there's an ISP router and it's 100 Mbps, right? So this company gave us this this connection. So we can buy two from the same company, or we can buy two from a different companies, just in case one whole ISP is down, then another ISP can be our backup, right? And both can be 100 Mbps if you don't want to, if you want to rely on the same speed. And some people go with little cheaper options where they will have two ISP routers. One is a little expensive, and the other router will be from other company with, let's say, 20 Mbps, right? And some companies, they will divide this by, like, let's say, okay, we're going to use this for all of our networking, and 20 Mbps will be used for some voice or other stuff.
Okay.
But, I mean, that's something you can talk about. But this is where it starts. So another confusing question will arise in here, that when we get these IP addresses, who are these people, and who are, like, in a networking side? Are these top level engineers, senior level engineers, who's going to sit down there and start breaking it down? And how does that work, like this whole flow from here? If you can explain that, I think that an architecture place will be pretty much easier for a lot of people to understand that.
Okay, as far as the redundancy concern, okay, first thing first, if we talk about for example, we have this ISP router here, okay, and let's say we have multiple, make it here.
And just high level explanation. We don't.
This is very high level. That's why I don't want to, but no problem. Let's discuss. This is like, in your case, this is one ISP, and this is another ISP. ISP1, ISP2. Okay. And then this design, you can either, again, it depends on the infrastructure or the budget and how your owners, they decide whether, if they have a good budget, they will ask you to deploy another router here as well.
And is that the gateway or something?
Yep. For let's say, if let's say we have the two redundancy as well. This was, I was talking about earlier, like HSRP, VRRP. These are the protocols being used for, these are the protocols being used for redundancy purposes. Okay. And it depends what kind of protocol you're going to use. For example, if I want to, for example, this is connected this one, and this one is connected this one. And we have kind of switch. And then switch is connected with our local area network, okay, LAN environment.
Yeah, and that's a pretty good explanation, because Christelle, if you look at this, this is a proper like a small network we were talking about. I mean, we're using 2 ISP. Usually in small, they even have 1, right? But if you look at that, sorry about that. If you look at the switch when he talked about, this is what he's talking about. Then in switching, core switches, and then after that, normal switches can be in the floors and stuff like that.
Yeah, this is a core. Exactly. Yeah. This is core switch.
Exactly, the core switch, and that's where you will learn a lot about switching. But if you go back to the routing again, you see it starts from that first, and a lot of new people, they're like always confused, like, where does it start actually? For me as a network engineer, if I go to this building right now and I know my provider is Comcast, but where does Comcast exist in my network, right? This is where a lot of people just don't know, like, what's happening over here. And that's where I wanted to take you back to this, because many people just don't know where it starts. So, the explanation of that ISP and then gateway. So how does like gateway works with ISP over here? Like that explanation, if you can make a little clearer than that one.
Mm-hmm.
And then I will just give a more explanation here as well. So sometimes what happens, it depends on these protocols I was discussing earlier, HSRP, VRRP, or GLPP. If we are using GLPP, this is known as gateway load balancing. Load balancing means, for example, we have multiple clients connected and they are using internet for some purposes, okay? Instead of putting load on this router using this ISP, we just divide the load using load balance. So what will happen? Some of the traffic will go through this ISP, and let's say some which is not most useful traffic, let's say, going through this, and some traffic that is not useful, but you are like surfing web, maybe could go through this. But it's yeah,
I think I got a little. So where does the BGP concept comes into play? There's a lot of people. Yeah, if you can explain that as well, because a lot of people will be like,
yeah, okay, BGP will be come into play here in this section.
In between ISP and
exactly. Okay. Yeah. And your HSRP GLBP has to do under your LAN environment.
All right, guys. So if you guys are listening these terms, right? So don't get worried about now, because that's too high level, and getting into that is almost CCNP, right? But CCNA, you're going to learn a lot of this as well. But try to understand that at this point, what you're listening from Kamran is just get the point, basically. Don't try to, I don't understand these terms. Just see if you can grab that point only, that how it's connected and who is working on it. And the reason I'm jumping in between, because I want to make sure that you guys don't think about something more advanced over here, because then you're stuck again. All right, continue.
Yeah.
I'm sorry about that.
Yeah, so GLP is very advanced. Even you will not cover in a CCNA. So you are going to learn about this BGP in a CCNP, by the way. So, but the concept of BGP is really they are directly communicating with ISP. So they have like the information about this gateway. If it is down, it will proceed from this. So we will have this kind of redundancy. Okay, so this one is down, or even the service provider is down. Our whole traffic will go through this service provider then. Okay, so this is the idea. And
before, I wanted to ask a question before you.
Okay, just if I can do Control Z. Yep.
Okay, thank God. So my question was to follow those after this concept. My question is about the IP address. When you receive the IP address from the ISP,
okay.
So what is the process after? Is it the ISP who give the address of the router?
That's fine. That's fine. Okay. By the way, we are going to give. I'm going to give you one lab on that as well. I will make a service provider kind of thing from where you will get the IP, public IP. Okay, and then your local area connections can communicate with your ISP as well. But just as I give you a high fly overview, how it will be. Usually, you know, if I give you example, just a minute, if you can go to this one. Do you really need to configure IP or something here when you connect your access point at your home?
I don't think so.
Yep. You never come across or you never play with this your public IP. Why? Your service provider have kind of technology or the DHCP services kind of thing. But that is not pure DHCP. That is known as PPOE. If you want, you can further dig deep on it. And it has kind of pool of IPs that will be given to you automatically. Okay, so you don't have to worry about these public IPs. And when you want to communicate, it will go through some kind of NAT. NAT is already pre-enabled on your access point. Okay, so your LAN, which is not routable, your local area IPs are not routable. So when it will hit the router has a capability to translate that your local IP into public IP, and then you can reach the whole cloud. So these IPs are provided by the ISP service providers dynamically. But if you are like running a business, like, you know, where you must need a dedicated IP, then you have to pay a lot of money for that dedicated IP. And then you can use that dedicated IP for whatever the reason or purpose you want to use. For example, you have one computer device here, and you have one CCTV cam here. You want to access that CCTV cam. You must have that static public IP. With the help of that, you can do a mapping to reach this CCTV cam. But that will cost you enough, you know, amount. If you will go for the IP, public IP, but this is dedicated from the ISP.
And most of the businesses will pay for that because they don't want that IP addresses to be changed, most of it. So, so for example, if it's a business, they don't buy one IP then. They would buy something in that range, multiple ones, because some they want to use it for internal subnetting, because they're gonna, engineers are going to sit down and then everything will just go start from that, because now you have just like you have one right now in your home, you have a public IP address. It doesn't matter what IP address is, you have the capability to open your network and do subnetting if you want to, right? You can put a Cisco router right now and just connect it with your ISP right now and start creating all these subnets, and you have no issues, right? But you have that one IP address that's given to you. What happens after that IP address is up to you. It's not what ISP decide what kind of addresses you need to put on and things like that. It's what you decide, right, Kamran?
Yep.
You correct me if I'm wrong, though.
Yes, exactly. But in case of if you are using router, Cisco router here, okay, then Cisco router has no like capability, you know, to automatically get this IP from the service provider and the netting, everything. No.
Yeah, you have to do that. Yep.
Yeah, you as a network engineer or network administrator will have to perform these all things by yourself.
And I have a question. When we receive the IP from the ISP, that public IP, do we do the subnetting on a private IP or on a public? Yeah, it doesn't make sense.
You don't have to. And you know, Crystal, I think keep these questions for the NAT, because once I will go through the NAT, you will have very good idea about what is going on.
Okay.
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 Yeah, for now, like the question was a simple answer to that is that you will buy the public IP addresses for organizations because that's what you own then, and you will use anything under that by using, like, your engineer is going to have to configure all these subnetting, like private IP addresses for companies.
Yeah.
So
you are responsible for your LAN only.
yeah, and
you have nothing to do.
And going back to the previous slide, your ISP routers are there. That's for routing for connection purposes, and then your gateway routers are there for your NATing and all that kind of stuff. That's going to happen on protocols. All kind of stuff is going to happen.
Yeah.
As well.
If I can give you example, like this connection will be connected with your router. That's why it is known as customer edge. So this is your customer edge routers, this one. This is also known as demarcation point. So this is ISP, and then this is your LAN. Whatever you want to do, you can do here. Okay, and then you need to do some kind of configuration so you can reach this service provider router. Okay, and I will discuss later. Yeah, so this is the old architecture, by the way. I was telling you earlier that if you want to, this is basically for, like, this is also known as campus network or infrastructure. If you do a Google search with the same keywords, the Cisco will take you to these 3-tier architecture, where you will see the same concept, where we have these access layers, distribution layer, and the core layers. Then the problem was the people don't have money to buy, first of all, these core switches separately, then distribution switches separately, and then access layers separately. It costs so much money. Okay, and a lot of configuration as well. So the Cisco came up with another idea, 2-tier architecture. So they just made these two things into one, which is known as collapse core, and these are the access layers. Normally your all devices will be connected here, because now these collapse core is capable of having core layer as well as distribution. So they are very high processing power devices, by the way. And these are used in data center. This is the infrastructure. And instead of access layer, these things are known as the pods or the leaves. Okay. And these things separately is known as VPCs. If you have gone through the cloud computing, let's say if I give you example of like AWS, Azure, or something like that, you will say the concept of VPCs. You can go through, I will not go a lot in detail, just I'm giving you the differentiation between these and these, how in your local area, how it looks like. But when we talk about the cloud, this is how things look like. They also have same core concept. Then these are layer 2 or layer 3 capable devices, and these are basically the pods, your end devices, because the host will not be connected. Here we have host connected, but here we don't need host connected. These are only the devices known as the leaves as well. So if you're not getting, no problem.
If I have a question, is there any circumstance we would use 3-tier today or 2-tier?
Yep. The circumstance is what, let's suppose this is your campus 1. Okay. In the same city, you have another campus 2 with the same infrastructure. What this host wants to communicate with this host, then these will be connected with these devices. Okay, you have end-to-end connectivity between these two campus infrastructure. And the reason of using these two 4 devices, 2 devices, because we want redundancy. Let's say this one is down. So what? Then again, we can, if not going through this, but we will go through this. Okay. And what if this one is down from here? Then what? No problem. We have, if this one is up, let's say this one is up, it will go through that way. So this is the basic idea behind this network architectures. We have 3-tier architecture. These are high-end CPU process and having a a lot better memory. But this 2-tier architecture, now Cisco has single solution for these two. That is the reason they just shrink it down to this 2-tier architecture. Got it?
Got it.
Then if I remember, she was talking about MDF IDF, so I thought I should add that one, because these have become the old concept, these two, basically these things. And these days we talked about the MDF and IDF, which is also nothing. As you can see, we have one main building, then we have like other campuses, if you want. Like this is a main campus and these are sub campus, and they want connectivity all the way, end to end. How they want, they will install one MDF here, which is main distribution frame, which will be connected to sub or IDF, intermediate distribution frame. So this campus can communicate with this one. If this one communicates this one, it will go through MDF. So basic idea behind that is, first of all, end-to-end connectivity as well as the redundancy. If you want to read, you can read like a cable rack, MDF, if talk about MDF, a cable rack that interconnects and manages the IT or telecommunication wiring between itself and a number of IDFs. So we have number of IDFs. Okay, so this is the basic reason we have MDF, and then IDF is an intermediate distribution frame. So these are intermediate distribution frame. These are wall mounting racks for managing and interconnecting the cable between the user devices and main distribution. So these are basically, if you want to communicate with IDF, it has to go through MDF. So this is a new concept, by the way, being used in these days. If somebody is saying that your MDF frame is down, or someday is saying, please, can you go to your IDF? So you have better idea what he's talking about. So evolution of technology, since, it's my habit to add the new concepts, although you are at very basic levels, but so what? You should have idea about what is going on in our, the new technologies and what is happening, and what you are basically, what is the new evolutions going on in our technology. So you must have a better understanding and idea about these technologies. So today what I'm going to talk about is DNS center. Okay, in old days, what used to happen, you remember I talked about that, for example, if you have just a minute. Let's say you have multiple switches in your architecture network, then you have, let's say, firewalls, then you have databases, then you have file servers, you have wireless LAN controllers. Just assume it like wireless LAN controllers. In our old days, what used to happen, they had these, all devices have separate IP addresses, okay, and then administrator, sorry, Then administrator is basically sitting here, IT admin, and he will just get the IPs of these all devices one by one. He will access, let's suppose, this device. He will make configuration. Okay, sometime he has to go into another system in another closet, and he has to perform the same thing like configuration. Then he has to come another closet and do something. Okay, so that was a pain. So for the solution to resolve that pain is a DNA center. We have a single pane here. Let's say this is Cisco DNA center, and your network administrator is sitting here. This is a single pane of glass from where he is looking everything. He is looking about these ISC devices. He's looking about these switches. He's looking at these wireless LAN controllers. He's looking at the routers. He's looking at these edge devices, clients, fabric access points, so many things. Even what IT infrastructure you have a single pane of glass from where he is looking at these all things and configuring. Even if he want to automate something, he can automate. What are the benefits I have added here? If you are interested, you can go through a lot in detail by Googling it out, DNS Center, and you will have better idea. So it is written, with the Cisco DNS Center, you apply policies to user application instead of your network devices. Cisco DNS Center allow you to run the network with open interface with IT and business applications, integration across IT operation and technology domains, and can manage heterogeneous network devices. Heterogeneous means multiple devices, no matter where they are, what they are doing. We have one single device, you can say device or the pane from where you can see everything. What it can do, you can design a network, that topology. You can run some kind of policies. For example, on this edge device, if you want to run, you can do it from here. You can do auto provisioning. You remember I talked about the provisioning? You have to go into that device and you will do it. But in DNS Center, you don't need to go into that device. DNS Center will do the auto provisioning for you. Then you can do topology map and diagrams, and you can control wireless technology and whatever. So this is the new concept you are going to hit if you will go a lot in detail, and if you go proceed for the future studies for the CCNP and even for the CCIE, you are going to come across with DNS Center. Okay, so officially we are going to start our routing topics from here. Krista, if you can tell me about what is protocols and what they are used for.
The protocols are a list of standard that is used by technology.
Yeah, okay, no problem. The same, yes, you have a good understanding. A routing, as it's written, a routing protocol specify how routers communicate with each other. Okay, this is the first thing. To distribute information that enables to select routes between nodes on a computer network. So the same idea, like we have multiple routers connected. And we have different subnets, like 10 network is here, and we have like 172 subnet network is here. If you will do the same thing in the switches, you connect this subnet and this subnet, it's not going to communicate. So you need these routers which will be running a protocols, kind of routing protocols that will enable you to communicate this network with this network. Not only this will distribute information, whatever, maybe the servers here, wireless LAN controllers, whatever the information here. If you want to distribute this one, you will have You will have to have these kind of protocols. These will enable these features for you. And what those protocols are, I have mentioned here. These are, the RIP is not mentioned here, by the way. I think it's pretty much gone, RIP. Oh yeah, it's here. We have RIP. This is very basic, and we are going to do the lab for that as well. So you have better idea how the protocol works, what is going behind the scene. So this is one of the protocol. Then we have this OSPF we talked about, EIGRP. So these are all protocols, but I'm just pointing out the famous, the well-known, and the BGP that we talked earlier as well. The BGP, it's I think not mentioned here, but we have the BGP as well. Okay, so these are the routing protocols that will basically help us communicate with each other. Then we have another thing, as I talked, administrative distance. And what are those AD and matrix? If I give you, yep, this one. So what is administrative distance? The administrative distance is a number used to rate the trustworthiness of the routing information received from the routing neighbor. It is used when a router must choose between routes learned using different routing protocols. Each routing protocol has a default AD value. I know this is mouthful, and it will be very confusing at this time of point, but just remember, this is the believability of your routing protocols. If you are getting multiple routes, okay, in our router, let's say if I give you example, I have these examples in subsequent slides, but just for the clarification, as it is mentioned here, different routing protocols. This is the recipe. And what does it mean by different routing protocols?
So, Kamran,
Yep.
Coming back to those gray areas of thinking around.
Okay.
So this type of protocol, the decisions are made probably right in the beginning of when somebody's implementing infrastructure, right?
Okay. Yep.
When let's say it's a school and we have to connect with different branches of our school, and I think based on that we would create some type of some of the best practices type of protocols. I guess that's what it is. And then second is like why do we need specific protocols for specific needs, right?
Yeah. Okay. Actually, really, Danish, sorry for interruption, but really I got the idea. But yep, we can go a lot in detail. Like RAPE is very basic protocol, and I know this is very small enterprise where we have small organization there we use, and these ISIS basically used in a service provider because it has more features and capable of doing so many things.
I see, and I think that's what I wanted to ask.
Yep. Exactly.
When it comes to understanding, like why do we use these? Who uses this protocol for what reason? Is I think the confusion.
So the Danish, the basic idea is, as I said, the basic idea. We have multiple subnets here, different subnet, this subnet, and this different subnet. We know that switches are not capable of doing these things. For different subnets, we cannot communicate with different subnets. If we have different subnet here and different here, on switching environment, we cannot do it. So that's why we need routers. And then routers should have kind of protocols that will be running on these all routers. So
in that we also have specialized routers to do different things because of the features it comes with.
Yes.
Okay, Chriselle, is it clear? You understand why we need these protocols, right?
Yes.
Okay, and then these routers have these protocols have multiple routing protocols, flavors of routing protocols. As I said, RAPE, ISIS, OSPF, EIGRP, and I also, I cleared this thing in the earlier slide as well. The OSPF and EIGRP. They do the same thing almost. But the problem is EIGRP is Cisco proprietary, while OSPF open standard. That is the reason service providers are using OSPF to make the communication. We have multiple vendors, like Cisco is connected with Juniper router. We have Cisco router, we have Juniper routers, and they want to exchange the information. If we use EIGRP here, it will fail. So that is the reason IEEE, they came up with the idea of having an independent protocol, which is OSPF. So if we have Cisco router here, Juniper here, we will run OSPF here in between. So now our information can pass through it. Then these RIP has some kind of issues. If I give you here right away, after 15 routers, if you connect 15 routers, I'm not gonna draw all 15 routers here, but let's say this is first router, and then we have multiple routers and 15 routers here. And let's say this is the 16th router here. And we have host machine here, and we have a host machine here. And this host machine, if you want to communicate, this host machine RIP will fail here. Because RIP works on hop count, which means, if you remember, we talked about tracer command, and we talked about TTL. If it becomes 0, it means there is a loop and it cannot proceed. So almost like same concept we have in a RIP. RIP can go to the 15th routers only. It can hop around 15 routers only. For example, this whole network is being used under RIP, and this wants to communicate. It will come here 1, 2, 3, 4, 5, 6, and all the way till 15. Now RIP knows that after 15, I'm gonna die. So this information will not go across.
Now, can it be changed later on? If somebody, let's say an engineer like me, who, let's say, are too new to this stuff, and I just learned about RIP, I implemented that, and tomorrow, now we got in a deadlock. What happens then?
Basically, the communication will not happen. But the another important part is, like, these administrative distance can be changed. Let's suppose if I give you example just for the 2 or 3 routers. This host or machine wants to communicate with this host here. I'm just giving you the idea why means administrative distance, which I'm talking about, not AD, but the metric. The metric is hop count. By the way, it is too early to discuss here, but no problem.
You don't have to go in details. Just like what we're discussing right now.
I'm just giving you overview, since this question is asked, so I want to clear here.
Mm-hmm.
And we have some other routers here. And let's suppose this is connected here in a LAN, and this device on the same LAN, and this connected with this switch, let's say here, and this is host machine A, and this is B. And let's say this is whole architecture is using RIP protocol. As you can see, we have multiple paths in between. One path to reach for this host to reach this one, it can either go through this one, sorry. It can go through this way. This is the first, and it can go through this way as well. This is the second path. So as a network engineer, the hop count to reach through this is less. Okay, so RIP will prefer this one because it is like 1, 2, 3, and I forgot to add another one. Let's say this one. So to reach this destination, it has to hop around how many routers? 1, 2, 3, 4, 5. These are 5 routers here. And to reach this same destination, I'm talking about the same destination. We have same destination here. To reach for this host machine to reach this destination, it has to go through 1, 2, 3 hops. So RIP will prefer this one. But we have to do kind of things. This is what is known as traffic engineering. And what traffic engineering is, I don't want to prefer this path. This path, I don't want to prefer. So what is the remedy? So remedy is the network administrator will come here and he will tell to this router, you are 16 hops away.
I see, like manually you put that in there.
Yep, manually you will put that this metric. So when I want to reach, now I have 2 ways to reach, but now I have manually put 16 hops. It means it is like 16, 17, 18 hop away now. Now this is not 3, but 18 hop away. And this one is still 5. Although it has 3 routers, but with the help of metric, I am able to achieve my task going through this path. Got it?
Yep, that makes sense. And I think the idea at the end is this, that, you know, when people look at it, when someone's so new to this stuff, this is why we need this different type of protocols for different reasons. And somebody has to go in there and configure it. Basically, a router will not come with stuff like that, right? It's like when you get in, you have to do everything in there. You have to add all these configuration in there, right? Come on.
Yes, exactly. And you gave me another idea, so I can describe here as well, since we are here. But how about the ISP? ISP have tons and tons of router in its domain. So do you think that they're gonna use RIP protocol there? Never ever, because RIP never goes beyond 15 routers. And we have, like, let's say we have here around 100 routers in the ISP. So opposed to RIP, we have another solutions or the flavors like ISIS, OSPF, EIGRP. Okay. So this is why we are gonna use EIGRP over RIP. So that's why we have multiple routing protocols.
Great, thank you. That was pretty clear explanation.
Okay, so you can read if you have any issues. Further, you can read, but I'm gonna go a lot in detail. So okay, so this is another slide: routing lookup process. What happens when we have a router? And let's say we have multiple routers. They are all connected with the same destination. Let's say X. And here we have this the source. Okay, so it means this router is learning multiple these destination from different routers. Okay, so but what happens? This source want to reach this destination. So when this packet will hit this router, what is going to happen? So this is I'm going to explain. When this source is opting for this destination and when will hit this router, what process it need to go through. So the first thing, as it is mentioned, inbound packets need to go through the following process. Find the longest match to the destination. This is our first step. After it found the longer match, either it could go through recursion process or it will go to the outgoing interface. And I'm sure you have some confusion here, so that's why I have a next slide ready for that for you, where I'm gonna explain this thing. Okay, so please pay your attention. This is first of all very informative, and it is gonna haunt you till your CCNP or even the CCI. If you understand it here, no problem. If you don't get it, just go through slide again, and what I'm saying, just go through again. You go to the Google and read it about a lot in detail if you have any confusion here. So here we have a data which is 172.16.1.1, and it will hit this router 1. Okay, then we have multiple destinations, S0, S1, and S2. As it is mentioned, these are the interfaces. So when the data hit this router, either it could go R2, either it go to R3, or either it go to R4. So how on earth this router is gonna know on which interface I need to go or exit? So this is the process of the longest match. What is happening here? This is routing information inside the router. Router has multiple destinations here, 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 which is learning from these routers. So when this source is coming and it is opting for this specifically this address, it wants to reach to this destination. This is the destination IP. And when it will hit the router, router will go through the process which is known as routing lookup, and under routing lookup, it will go through the longest match. It will always prefer the longest match. And how? I'm going to show you. Just compare this destination with the first one. Okay. So let's start from here. 172 match with 172. 16 match with 16. Okay, that's fine. After 1, you can see there is no match. This is 0 and this is 1. So there is no match. So it will skip this one and it will move further. It will look into this destination, whether this is matching with this criteria or no. Let's see. 172 match with 172. 16 match with 16, and 1 matched with 1 as well. So if you compare these two, you can see this one is more like the copy, or can say compatible with this one as opposed to this one. So this is gonna prefer always this one. So this will be its exit interface. So it will go there. The information will be sent throughout this. Got idea?
Yeah.
Okay. I have another example, and I want Crystal to solve this for me. So Crystal, this is the data is coming. It has multiple destinations to go through. This destination here, this destination here, this destination here. So once the data hit this router has to go through the longest match process, and it will find which is most likely like compatible with this source. So then it will send out to the particular interface. So although the answer is there, but I want you to explain why this router choose this one.
Okay, I think
you can start from here. You can start from the first one.
Okay, so when we start with the first entry, in match, 172 matches, 16 matches.
So
but one doesn't match.
Exactly. Okay. So it skipped that one and then came here.
Yeah. So in the
Then,
second line, 172 match, 16 match, and
okay,
yes, we stop there too.
stop there too. Why? Because
Doesn't
this
match.
is like doesn't matter. It doesn't care. Where we have zeros, it means it doesn't care, whatever it is here.
Okay.
Okay. But this subnet is different. We can see we have one here and we have two. Okay. So this is a clear cut, like can say the contradiction between these two. That is the reason it ignored this one. It came to here and it checked out that at least these two are more specific to this one. Okay.
Okay.
Because it ignored these two, the rest of it. So if this is gonna prefer S1 interface. So whenever this data will hit this one router, it will go through this longest match process and it's gonna send this information here. Then I have another one, which is gonna clear your default gateway concept. Okay, so Crystal, tell me, you can start from first, second, and then you will come to this one. Just tell me the logic.
Okay, so we start to match the first entry.
Okay.
172 match.
Okay.
17 don't match. We're gonna
That's
go
fine.
to the second entry.
Okay.
172 match. 16
Okay.
doesn't match.
Okay.
So we gonna take the default gateway.
Exactly. So this is the concept. If nothing matched to this destination, or this is the source where the source packet is coming, but this is the destination it's heading to. It will go through this 172 match, and afterward 16, 17 there is a contradict. So it will ignore this one, it will ignore this one, and it didn't find anything. So your default gateway is intelligent enough, your router is intelligent enough, when it will hit something, get some the destination, something like which is not inside its routing table, it is always gonna send to this one default gateway, even it is destination is 111, 222, 333, 444. If that thing doesn't exist in a routing table, it is always going to prefer this one. Got it?
Got it.
Okay. So since we are here, I just want to explain more. Let's say we have another match here, 172.16.2.1/24. Just a minute, I will clear this one. (172.16.2.0/24). Let's say this also exists somewhere here before this default gateway. So can you tell me, Crystal, now which is gonna prefer which longest prefix is gonna match with this one? Do you think it will go through this one?
Wow.
No problem. Just compare. That's it. Match it.
Yeah.
Which has the longest match you are gonna prefer.
172.16.
Okay.
.00. Yeah.
Why?
Because it's match 72.16, and you say that the 00 don't matter. So
Don't match. But what I said, the longest match. Don't forget this concept. If you go through this, just compare this one with this one. Where you rate. Compare it.
So we're gonna 172 match, 16 match.
Okay.
2 match.
Okay.
And we don't care about 0.
Yeah. So don't you think this one is gonna prefer this thing is gonna prefer over this one?
Okay, I didn't understood the question. I thought that the address that you marked down was the data, and I was matching with the entry.
Okay, sorry for that if you didn't
now
get
I
me.
understand. Yes.
Okay,
yeah.
no problem.
The longest match now, yeah.
Okay, I want to ask another question here.
Sorry.
You know, sorry, Christopher, I'm asking and hitting again and again. This is, you know, very important concept. If you get this, you're, you know, the further when you will move, you will see, you will feel so much comfortable. Okay, let's suppose we have another, this is not destination. This is like in your routing information, this prefix exists. So this thing is here somewhere.
Okay.
This is what's gonna go through, or which one is going to, you know, choose it as a destination.
The entry that you just entered, because it matched with the data exactly.
Exactly. This is the most, you know, perfect longest match. This is one-to-one match.
Mm-hmm.
So this is going to, the router is going to give the priority this to over this, and even if they have 172.16, even until here, like we have here, yeah. Okay, because this is exact match, and we know the longest match is always gonna prefer. Okay.
Okay.
Any questions from Hefa? If you can write down, or if you have any confusion, you can ask.
I think she's good. No question
Okay,
for now.
that's fine. That's fine. Okay. If you can see in my last slide, I said find the longest match to destination. Then we have the route recursion and outgoing interface. I forgot to mention that as well. This is our destination. This is our destination. And let's say this is our source. So if this source want to reach this destination, it has go through this router. Then this router will be saying that if you want to reach this destination, you need to go into this router. Then this router will be saying if you want to reach this destination, you have to go through this router. And so on until you reach this destination. This is known as the recursion process. Recursion, route recursion. When you have to go through multiple routers to reach the destination. On the other hand, outgoing interface, of course, these have some outgoing interface when this router will be thinking that if to reach this destination, I have to go through this router, but I need to go to this exit interface, this exit interface, this exit interface, and this exit interface to reach this one. So this is the concept of route recursion and outgoing interface. But sometimes what happens is on the same router has the destination. So it will come here. It doesn't need to do route recursion. We know this is on the same router. And it has only to do with exit interface or outgoing interface. So when the source will come, it is looking for the destination. It will no need to do route recursion. It will go directly to the destination, opposed to the route recursion that has to go through this whole process. I hope you have a better idea. about that after that. So the longest match we have gone through. This is also very important part in the routing lookup process, that is AD. After the longest match, let's suppose we have multiple routing protocols. So this is the destination. This is destination. This is our host machine that is looking for to reach this destination. And this destination is advertised via so many ways. Like this, we have RIP domain, we have EIGRP domain, and we have OSPF domain. So it means the same destination prefix, this router is learning from multiple path as well as protocols. As I mentioned, RIP, EIGRP, OSPF. So what is going to happening on this router? For example, this computer is in question. It's looking for this destination. So which path this router is going to take when it is learning the same destination from multiple paths with multiple different routing protocols? How this router on earth is going to know which path I'm going to process first, or which path I'm going to prefer? So this is where AD comes as a tiebreaker. And if I take you to the back, the earlier slide where I was talking about the administrative distance, if you see, if it is directly connected, it has administrative is 0. What does it mean? For example, these two routers are directly connected. Okay, and this wants to communicate with this router. Since it is directly connected, so administrative distance is 0. And I told you what AD is. It is the believability. Believability means it is gonna prefer what? Of course, if it is directly connected, then it is, without, looking at other protocols, it is gonna prefer this one. Because this is directly connected. Then we have static routes, and I will discuss static routes in give you a practical scenario as well. So static route, if some router is there, some host or some prefix is there, I want to reach this one, I statically will define on this router, if you want to reach this prefix, you have to, your next hop is this one. So the believability is 1. It is not directly connected, but it's connected somewhere on the router. But I am telling this router, please, if you want to reach, I have configured static route to reach this route. So this is the believability number 1. AD is 1. Then we have a RIP. Well, I always forget RIP here. This is 120. And when we are running RIP protocol in our environment, this is where router will choose from which one I need to prefer. This is the believability. And EIGRP has this 90. And OSP have 110. And I'm going to show in that slide, then you will have better idea. Just a minute. Yep, here. So as I said, RIP has believability 120. OSP have 110 and EIGRP has 19. When this router will check into its routing, go through the routing process and will look into its routing table. I just putting RT routing table. What do you think, Crystal? Which path is gonna prefer? RIP, EIGRP, or OSPF? I know you don't have a better understanding about the protocols, but just give me a hint or just a guess which one is gonna prefer, RIP, EIGRP, or OSPF?
I think EIGRP, because
Why?
you say that the trust is the
Exactly.
number is
You
the
are
trust.
very good, Krista. Very good. It is gonna prefer EIGRP because this is less than this RIP and this is less than OSPF. So EIGRP is always gonna prefer. But why we are using routing protocols? This is the good point we can mention here. So let's suppose now this time EIGRP is down, but still this destination is reachable via this path and this path. Now tell me which one is going to prefer. Krista?
Yes, I'm here. Sorry, I was trying to look at the AD.
Okay, no problem.
Like you didn't.
AD, sorry. This is 120.
Yeah.
And OSPF 110.
Yes, he's going to choose OSPF.
Exactly, this one. And now let's say this one is down. Then this is the last ditch effort.
Yes.
Okay, so this is where AD concept come into play. When we have multiple protocols and we are learning the same destination. Got the idea?
Yes.
Here comes metric. What in case that we have the same scenario, but then we have multiple paths to reach this destination, but we are using the same protocol, which has same believability, 120, 120, 120. Now, administrative distance. Crystal, can you tell me what is going to happen?
If we are using the same protocol, we're going to use the metric.
Yes. And what is metric for the RIP?
For the RIP, is it the hop?
Hop count. So AD will be ignored. Now hop count will come into play, and you know what hop count is. Hop count, to reach this destination from this source, if it choose this path, it will have to go to how many hops? 1, 2, 3 hop counts here. It will choose this one. Let's say 1, and this also has 1. So do you think it's gonna choose this one?
No.
No. So this will be excluded. Now we have a tie between these two. This is also 1 hop away. This is also 1 hop away. So what's gonna happen? Just give me your, like instinct or your guess, your sixth sense. What says?
Okay. From my understanding, if we have the same, one up, the tiebreaker will be the bandwidth. If the link are different.
Okay. No, we have decided for the metric for the RIP is hop count.
Oh, okay.
That's it. This is a deadlock. You have to use the same concept, and we know it is a tie break here. Then what will happen?
Then we can choose either one. No?
Okay, no problem. We will do, we will choose both.
Oh, okay.
Okay, so this destination will be like reachable via this as well as this, like a redundancy we have.
Okay.
Or we have multiple paths. Okay, but in case, let's add, I'm going to add here router. So what will happen?
Now it's not, it's now the second part have two hops.
Yep.
Yep.
Yes. So this will be excluded.
Excluded.
So the only thing left is this one. So this one is preferred. Okay, and these two will not be preferred unless until this one is down. This router is intelligent enough. That is the reason we are using, protocols. This router is intelligent enough. He has these paths in its database. It has kind of RIP database where these paths are available. When this one is down, but RIP is, it's very slow convergence protocol. It's going to take around 25 to 30 seconds, to calculate again and to reach through this destination, because now this is 3 hop, this is 2 hop, and this one is down. So this is 3 hop. Since this has 3 hop, it is going to reject this one and it's going to prefer this one. Okay.
Okay.
Got the idea? Any
Yeah.
confusion, Hefa? Any confusion? This is very, I'm not telling you again. This is the most important topic in routing. If you get the idea, you can move along with other, concepts. Otherwise, if you stuck here, I'm very sorry. In future, if whatever you are studying, you will be facing problems. Eva, any questions, or shall I proceed?
Yeah, you can.
I don't see IFA.
Okay, no problem. So let's talk about the dreaded network address translation we were discussing about. I gave a very simple analogy with the help of this diagram. Have you ever come across, or maybe it happens a lot, when we have this Chinese prime minister is talking with this, let's say, United States prime minister, you will see always one person sitting in between. And what is the purpose of this person? She will listen from this Chinese, it will do the interpret and will convert it into English and will tell the prime minister of the United States. And similarly, this prime minister, when I want to communicate with this Chinese prime minister, is going to talk to this lady first, and then she will translate it to Chinese. So this is the same, idea or the concept behind the NAT as well. We have LAN environment, as we discussed earlier. Then we have router in between. Then we have segregation point, ISP we have here. ISP using live IPs, or they can say public IPs. This is using your RFC 1918 addresses. As I mentioned here, I gave this interpret example. Then it's mentioned RFC 19 are not routable. If you want to communicate with the ISP, it is not possible, because these are for your LAN. It cannot communicate with your public IP. Your public IP will not understand this Chinese language with this American and English language. So that is the reason we have one interpreter, which is NAT. It will convert whatever the IP here. It will just change, do the kind of encapsulation. It will convert into the public IP, and then it will be reachable. And when this public IP wants to communicate with the LAN, it will hit this router, a router is intelligent enough, it has this NAT process, it will convert this public IP into a LAN, and then this is how they're going to communicate both ways. Another use case study when two companies are in a merging process. What does it mean? Let's say we have not these, that's not good. I will not name some companies here because I don't know, because it's kind of confidential. So I just make a name like ABC company here, and this is some DEF company here. These are like group of companies. This company decided to own this company. This is using, let's say, 172 subnet, 172.16.1. something X. And this is using, let's say, 10 network. That's 16. How they both gonna communicate? The first thing is either you can use routing. But let's say this routing is some kind of barrier with them. They cannot use routing. Then what is the remedy? This NAT. You can enable NAT. This is how this LAN will be able to communicate with this LAN. Here will be some process, which is I'm saying the NAT. It will convert this IP into this IP and this IP into this IP. So this is how they both gonna communicate. So this is a very good use case being used in the organization if they want to merge these two companies together.
And of course, if they are physically separated, then they will be using some type of firewall, and then that gets into that same, like
yep,
they will be doing some kind of connection between firewalls.
Exactly.
Yeah.
It depends, it depends on the criteria. So this is one of the criteria. We can use NAT as well if you want
to connect these two. Yeah, and then there are situations where this happened. Companies buy other companies, and the networking is already done, so they don't want to, they're not going to go and start subnetting again, because if things are working at so deep level, they will just connect them.
Yeah, exactly. And another use case is hiding your LAN out from outside network. Although some people, they call it like this is like a security NAT, but it doesn't come under security. But just you are hiding your private infrastructure from the outside. So this is also another use case of NAT. So we have multiple flavors of NAT, as I was discussing earlier in the Discord. We have static NAT, which is one-to-one. We have dynamic NAT, which have the pool of IP. And then we have dynamic PAT, not only the pool of IP, then we have the port addresses as well. And what are these? I'm going to explain. What is static NAT? Static NAT is, this is the segregation point. This IP, public IP, is coming from our ISP, let's say dynamically. And we have only one IP. And we want this device to communicate with this web client. It will have to go through this static NAT, which is known as one-to-one mapping. So this IP will map with this one as a one-to-one relationship to communicate with the web client. But what in case if we have multiple devices there? But this has already consumed this computer machine already has consumed this public IP. This is dedicated for this one. So what will happen to these? They will starve. They cannot reach internet. So then we have another solution that is known as Dynamic NAT, which I'm going to discuss earlier, but you can go through this definition as well, what I have written. Static NAT address and static NAT is one-to-one mapping, as I said earlier. This will be one-to-one mapping with this one to a public address. This is a public address. Static NAT network technology is useful when a network device inside a private network needs to access it from the internet. Or another case scenario, this is also, this static NAT is also very helpful when you have gotten, like, let's say 10 public IPs. You are rich enough public IPs from your ISP, let's say AT&T. You have 10 public IPs. And you have, let's say we have one SQL server here. We have email server here. And let's say we have some CCTV cam server here, which are connected. So with the help of, let's say you have one machine, or let's say we have multiple machines, they want to access this these servers. But you can do what? One-to-one mapping with SQL static map. If this want to reach this device, it will be go through this one public IP, which is allocated by ISP, and then it can reach. But this one is dedicated to this only device. It means other device, they cannot reach SQL server unless until they have multiple IPs. Okay, so that is the
see this static used in a lot of those like, when you try to download a VPN connections, like people would say remote.jss.com, right? And because that is your own IP address, so you don't want to then do like any internal subnetting on that IP address. A lot of people will like just give one IP to that, because it's you look, if somebody say you're my client and to get access to my network, you need to download a VPN. Then how you download the VPN? You have to give them that tool, right? So a lot of people would use one IP addresses for that type of like remote.jss.com, and that one static IP is reserved for that only. Then, so then nothing is beyond that. It's just that one IP is gone. You gave it to them.
Exactly, that is one-to-one mapping.
Yeah, and you can. And a reason why people do this, because you have clients that are gonna need to get that client and download it without any, them calling you, hey, send me the file. People don't do that, right? You need some kind of web address so to download it, and to expose that IP address, then you have that one just given out like that, because now you don't want to be giving your router IP address that has all the subnetting going on. Nobody does that. So that's why it's companies they buy few ones and then they just separate it out,
Yep, exactly. So the drawback is one-to-one mapping. If you want another computer device, you need another public IP, and then you can give access to this one. So this is the drawback. So to overcome this problem, we have Dynamic NAT. Now in Dynamic NAT, I said we have a NAT pool. We have one public IP, but we as a network administrator will define the pool of IPs from the same range. Okay. And then with the help of these pools, now what we were facing the issue earlier, now we are overcoming this one. This is also, by the way, one-to-one static mapping, but in a fashion of like dynamic. Now dynamically, it is mapping. This computer, if wants to communicate with this server, it will choose one of the IP from this pool. It will communicate with this one, and then this one will take it to the web server. But again, that IP now has become the part of this one. No other computers can use the same IP. But since we have configured the pool of IPs, now this computer is gonna select another IP from this pool and it can go out. This device again select the pool from it and then it can go. Okay, if you want to read the definition, it's dynamic NAT transfer can be defined as a mapping of a private IP address to the public IP address. A group of public IP addresses is called NAT pool, which is this one. Dynamic NAT establish a one-to-one mapping. As I said, this is also one-to-one mapping between private IP address to the public IP address. These are the private IP addresses and these are the public IP addresses. So these are the dynamic pool we have from where this system can pick. Okay, and here the public IP address is taken from the pool of IP address configured on the end of on the end NAT router. So this is the concept. So you will be confused. So what is the difference between static NAT and dynamic NAT? In static NAT, you have to do manually. Means you as an administrator go here, you will assign this computer or this IP to this pool, one of the IP from this pool, this one the IP from this pool. Then you will come here and assign to one IP from this pool, and this is very hectic. So that is the remedy. Dynamic NAT automatically it will pick from the pool. But the problem here is again, we have like multiple pools we need to buy from service provider, and you know one IP how much cost? It costs a lot. And what if you have tons and tons of computer in your LAN environment? And do you think you want to give one IP to this E? No. For that, we the engineers came up with a solution known as PAT, Port Address Translation. And what is it? You can see we have this one single public IP, and we have this let's say another public IP, which will be assigned to these all hosts. So same IP will be assigned to this, same IP will be assigned to this. But now you will be thinking how this router is gonna know from which device this request is coming from, because they are all have the same public IP now. So to solve that solution, they have to add TCP ports. And we know that how many TCP ports available on devices. 0 to 65,535, out of which we have like 0 to 1023 are considered to be well known. So it means we cannot use these one. So out of which from 1024 to onwards 65,535 we're gonna use randomly. So what is gonna happen? This router will be assigned this public IP with the port number, let's say 3333. This one will be assigned for this public IP to distinguish this one 444. This one will be assigned like no, actually I said 1 to 1024 are the well known, so we are not going to use this one.
Yeah, we can just put like 80 and 443 because a lot of people are used to that.
Okay. No, but these are the source ports.
Oh, okay.
As I told you, these destination ports, these are well known, like 80, 443. You cannot change this one. So the public IP needs to know this request is coming from which host machine. So to distinguish that one, it's going to use these 1025 all the way to 65,535 random ports. So let's say assigned to this host is 1026, and this one is assigned with 1027, and this one is assigned with 1028, and this one is 1029. So the request when will come from this host, it will identify that, this I have assigned to this one, this I have assigned to this one. So this is how it is gonna know about. So as you can see here, I have mentioned here as well, port address translation is another type of dynamic NAT which can map multiple private IP address to a single IP address using technology known as port address translation. But random ports number will also be there for multiple sessions. As you remember, we talked about NetStat. Under that, you can see we have from the same machine, 172.168.1.1 has different random ports assigned. Okay, the same computer 172.168.1.1 is coming from different random ports assigned. Why? For keeping it multiple sessions. This is how it will distinguish between the multiple sessions. So the same concept is in the NAT as well. So NAT will assign multiple random ports to this. So just it will keep it in this table. It will keep that information in table which is known as NAT table, that this request is coming from where. So when this request will come back again, reply, I have better idea where to send it. Okay.
Another practical example, if you want to see, every one of you have home routers. Log into the home router with 190, 192, 168, 1.1, or whatever your router address is. And if you log into your router and then you actually see the connections, it's going to actually show your private IP addresses calling different type of ports. And it's going to tell you exactly, how that works, because that is how you're going out. But then when you're going out, that one IP address is being used then, but it's different ports. If I have, if I want to use, let's say from one machine, port 443, right? And I want my public to actually access that machine. The public will actually not know anything about 172 address, and they will just need to know about that public address with that port. So on our router, actually, then we need to make sure that that port is basically open and actually connected to that private IP addresses. Do you guys see what I'm saying, right? So if it's a 443 from that machines, I need to tell my router that I want you to expose my 443 to that public IP, that private IP address, and everything will be then converted using this PAT method, right? Right, Kamran, is that correct?
Yep. And don't worry, in the last, the time permitted, in the last, we have one lab for the NAT as well, and I will show you this PAT as well.
So Kamran, usually in our home networks, we use PAT, right?
Yep. Yep. Because
the other ones won't make any sense, because even in home networks, people have 10, 15 devices these days.
Yes, this is the most common being used everywhere. Why? Because we have multiple devices at home, and they, we are not rich enough to buy different public IPs for every device. So we just buy one device, and with the help of these random ports, we just distinguish these all devices. Got it?
Got it. I have a question.
Yep.
I would like to know, when we have the public IP address, does that public address is the interface
Sorry,
of
the
the
public
router?
IP. I didn't hear. Public IP address is.
Yeah, when we get the IP, the public IP from the ISP, is
You
it?
don't when.
Oh,
Yeah. Go ahead.
sorry.
Go ahead.
Okay, so when we get that address, that public IP address, is it the address of the interface of the router? I mean, the outgoing.
Yes, you are right. Usually, if I can show actually, in the back of your router, you will see, or the access point, you will see one port. Maybe it is written like WAN here. Okay.
Mm-hmm.
And then this WAN is going where? We have no idea. Somewhere in, outside, this is known as DP, distribution point of the ISP.
Mm-hmm.
It has some kind of box, okay, where this your connection is connected, and which is going to connect with your ISP, okay. And then ISP has kind of router which is handing over these public IPs, because ISP purchased those public IPs from IANA, IANA, which is, I think, stand for International Assigned Number Association, something like that.
Internet Assigned Numbers Authority.
Yes, this is an authority that basically going to give this ISP some kind of slots of IPs, which is then they will do the subnetting on that, and they will assign this dynamically to your machine. So you don't have to worry about this. You just connect this into your WAN, the cable that is coming from the ISP, and then there is given usually 192 subnet, okay. And then router, you don't have to worry about the netting, because in their software it will be like something like that, NAT. So they just enable this checkbox, and that's it. Whatever the communication.
Home router.
Yep, home router. So whatever the device wants to communicate, automatically it will translate. But in case of the router, you will have to do everything manually, which I will show you.
So in a Cisco router, you would have two interfaces like that. One would be, sometimes you look at the back of the router, it says G0/0, right? And then one would be G0/1. So you would assign one for that WAN, and that's it. It's just, you're getting the connection from it. Then through that, you have to do the natting, padding, whatever it is, to let the other interface go through that, right, Kamran?
Yes.
Other Christelle, I have actually created a whole network using a Cisco router, using this, natting and padding. I didn't go in extreme detail, but in that video, I'm going to share that with you. In that video, I show how to use a Cisco router and a Cisco switch on a home network. So once you see that video, it's going to give you a pretty clear understanding of how I used a normal ISP for my internal network, and then I went outside by using that. And I showed how do I connect the 00 port, because that's a WAN. Then I showed how do I connect the 01. Then we did the whole configuration in that router, and everything went through. So now, if you watch that video, in that video, I say to people, I'm not going to explain what is NAT. I'm not going to explain what is PAT. I'm not going to explain none of that stuff. I'm just telling you that's how it works. But today, if somebody watches this lesson in a very detail and do a little bit of research in the testout.com, and then go to Google, I can guarantee you, if you watch my video after that, you would have 100% understanding of what happened actually over here.
Okay, thank you. And lastly, just for confirm that I've well understood the concept, when I receive, or when we receive from the ISP in a home, home network, when you say that we can only have like 15 devices, it's because they gave us an address with a subnet mask that offer 15 devices. Is that right?
I didn't get.
Oh, sorry. Okay.
So the question is, maybe Kamran can explain that better than me. The question is, Kamran, that let's say if I buy one public IP address. Am I somehow limited because of that IP address? Is this my limitation? If, let's say, for example, I have 200 machines, does giving IP addresses dominate how many machines can I get on top of that, or it has nothing to do with that? I think that's
no, it has nothing to do.
Okay, yeah, exactly.
It has nothing to do. It depends on what kind of subnet you are using in your local environment.
Okay,
if you are using like 192.168.1.x, it means you are limited to 1 to 254 devices only.
Yeah, but this has nothing to do with the public IP address, right?
Yeah, it has nothing to do with the public.
Thank you.
Another example, think about it. You have home ISP right now, right? That it's up to you. You can connect one router right now in your home, and that router will have a limitation of, let's say, because of that automatic subnetting that they have given to you. Let's say 254 addresses, 255 usually. We never use that, right? And you have around that 200 IP addresses. But so you can connect 200 at this point. You can go right now and with that router plug in a new router. So what's going to happen? You're going to configure that router to say, I want you to use 192.168.2.1. This is going to be the gateway of that router. So you can connect multiple routers like that right now, and you're going to have all these addresses going through your IP address. It will have no impact. As long as you know how to connect those other routers, will have no. And we did that so many times in our labs. We have multiple labs from different subjects, and we have many people using different, using under one IP address. So that's how. Yeah, I do that project. And she just texted in the chat that I will do that project. That's a really good project, by the way, for people who are in home and they want to understand how these NATing and PATing works. I want to challenge people like this. After watching my video, I know maybe you will configure your Cisco router from using your normal home router. So let's say you have 192.168.1.1. That is your normal home router, and then you have a Cisco router. So you are successful. You're like, okay, I made it through. I want to challenge everybody now. I want you to connect a new router inside your network and call it 192.168.2.1, and I want you to make that go through your network and see how much you're going to learn that, because that's where you're going to understand how am I going to now pass through this whole network from router to router, and then ISP is a challenge for a lot of people. So go ahead and try that.
Great. So any conclusion until here, or shall I go to proceed?
Good.
Okay, that's fine. Now, Crystal, you have a clear idea about what is NAT?
Yes.
That's great. So here comes the lab. Basically, we are going to hit 2 labs. This is, I'm just going to talk about static route and RIP IPv4 here. And this one is also like, I don't know, Danish, you can clarify me, because this part, just now you said that you gave the challenge. So that's why, shall I proceed for this part as well? Because here we have netting going on.
Yeah. For lab, maybe you can do like the basics of because maybe people want to know now that how does it look practically.
Okay, that's
so
fine.
If you can just show the basics of configuration, I think that's what we want to know at this point.
Okay, that's
I'm sure
fine.
people are gonna now they get stuck in this and they may have questions. Okay, how then that we don't want to go into that detail, because let them figure out how can they move, how can they get connected or make that
exactly.
Because that's where you're going to have more questions. But at this point, I just want you to just show them the practical side of what you have covered.
Exactly. And we will go piece by piece, and you will see this will be very informative. And if you have gone through this and you have idea, I'm telling you, in future, whatever you're going to do, you have better understanding what basically you are doing and what you have to do next. Okay. And all your future concepts, depends on these basics. So this is basically the switching part. I added this because I was so curious, to touch the lab. So that's why I added this lab. And we have since gone through the VLAN, Sprung, and NAT, ISP connectivity. So I thought I should add this as just for a fun. You have better idea how. By the way, have you both installed Cisco Packet Tracer and did some hands-on labs on that, or still with?
I think both of them said that they have that already configured. Christelle, you said you had it before us. So
yes, I used it before.
Okay, that's great enough. Then I don't need to make you understand about the Cisco Packet Tracer at least.
yeah, we don't have to talk about the
Yep.
devices and
Yep.
stuff.
Okay. Okay. That's fine. That's fine. Just a minute. Let me start the Packet Tracer. And I think it is not visible. Can you see the Packet Tracer?
Yep.
Yes.
And this as well?
Yes.
That's great. So I'm gonna, deploy this from scratch. So let's start from. Also, you can see the slides, huh?
Yes.
Okay. So we will start from this. How your LAN look like. Okay. Then piece by piece, we'll connect this one, and we will further move this one. And if you think that it is going too much, then we can really stop at that point for you to feel some, okay. First thing first, we need to add these two computers. So you can select from here these two pieces. And then we need to add two switches. And we know what switches does. It will just broadcast whatever the information it will receive. Then I want to just connect these two very quickly. So I will use auto because I don't want to go into detail. For the sake of clarification and topology, to keep it neat and clean, I will just give the IPs. Let's say we are giving this IP from 192.168.1.1 and this one 192.168.1.2. Okay, so I'm gonna assign IPs very quickly. I will go into the desktop under IP configuration and IP 192.168.1.1 and automatically it got the subnet. Similarly, this one, desktop IP configuration 192.168.1.2, which is on the same subnet. So my first step is I want to ping these two devices. Krista, can you tell me that whether I will be able to ping this device from this or from any end?
You're gonna go to command prompt ping.
Yeah. First, I will check IP config. Okay. So because I want to know where I am. Okay. And now I want to ping 192.168.1.2. Will I be able to ping this device?
Yes.
Why?
Because it's green and the connection are up. So I think there's no the connection.
No, it has nothing. No. I want to understand the logic basically. Why it will be able to connect this one or ping will be able. Yep.
Because it's the same network?
Exactly. This is what I want to know. This is from the same subnet. That is the reason it will be able to communicate. And we have no any aggregation or segregation point in between, like the router. Okay. If we connect router in between, no, then the logic will tear apart and they will not be able to communicate. Switches does the broadcast and they have nothing to do with these IP subnets. Okay, so that is the reason it will be able to ping. So as you can see, I can ping. Okay, regarding the CAM table, I told you, if you click on the switch, go into the CLI, and this is user mode. Want to go into enable mode and type command show MAC address table. Now you will see it is learning about these computers, these devices. So, just for the clarification, what I'm going to do, I'm going to add the ipconfig/all the MAC addresses as well. So this is how you have very better understanding what is going on in our network. So ipconfig all, this is my physical address, and you have better idea from where you can get these physical addresses. So this is, I think, for this device. I'm not wrong. 1.2. Yep. So this is the physical address of this computer, this machine. And if I want to get the MAC address of this one, I can get from here. Copy and paste. I will show you why I am giving these MAC addresses here, because we need it to understand the deep packet, what is going on. So, in my last section, I haven't touched upon one thing, which is, it's awesome, which is this simulations. If you click on this simulation, you can see we have multiple filters: ARP, BGP, Bluetooth, IPsec, POP3. These are all protocols. We can filter out. We can check how, just like, the Wireshark, if you want to know how packet traverse from one location to another, when it comes to Cisco packet tracer, this is the best. This is awesome. And I'm going to show here. So what I'm looking for.
That's awesome.
Yeah, I'm looking for ICMP, because if I go edit filter, you can see this is all selected. So if you want to deselect this one, just click once on this one. So you can see the filter has been cleared now. Now click on the edit filters and select ICMP, because we are going through the ICMP section currently, because ICMP basically is nothing but the ping. Okay, so we selected this protocol, and you can see it is there. Okay, so we have filtered out the ICMP. Now select this packet, add simple PDU, and once click on this one, and then click on this one. So now my packet is ready. If you want to go a lot in detail what this packet is, just click on that. This is my OSI model, which is talking about all 7 layers: physical layer, layer 2, layer 3, and these are public. And if I can correlate MAC address, you can see the MAC address if it is giving here for no, because we are here 00C CFBF. Again. So this is the MAC address. It is going to show here. So it is telling me I'm sitting on this computer, and this is my situation. So let's go ahead, and if you click this one, it is saying if last event captured the forward. So I want to move forward. Click. You can see the packet has reached to the switch, and you can see at device what is coming from where, what kind of packet is this one. This is ICMP packet. Now, if you go click, see what is going on here. We know that just by looking at this packet, we know that this is in layer, we're basically coming in port, and it is leaving port, egress port, ingress port basically. So this is our layer 2 Ethernet. This is our physical layer 1. It is saying it is hitting my fast Ethernet 0/2, which is correlate with this one. My exit interface is this one. And you know, when these two computers want to communicate with each other, they will use what? Initially, they will use IP to communicate. But if they don't have this MAC address information, we said or we discussed in our earlier videos that it's going to use the ARC and with the help of MAC address. They have nothing to do with the IPv4 at this stage for the communication sake. First, they have to go through these MAC learning. Okay, what MAC address this computer has, what MAC address of this computer has. And these are burn-in addresses, you know, when the companies, like, you know, the companies that manufacturing network interface cards, they assign one unique IDs, which is known as MAC. In all universe, you know, for every device, this MAC will be unique. They cannot be same. If this is same, it's a blunder and the communication will not happen. That is why this is, you know, very essential part of any device, the MAC address. With the help of MAC address, they are going to communicate initially. Afterward, then they have found each other's MAC address, then they going to communicate easily. Otherwise, they send flooding, you know, if you remember, we talked about the flooding. So this is just the flow. So at this stage, now you will see the packet here. When you will click, now it went there. Okay. When you will click further, now it has received. And if you want to go a lot in detail, you can see now it has to do with the IP. You can see when it was here and here, it was just talking about layer 2 and physical. But now since it hit layer 3, and we know at layer 3 we have routers, we have computers, because they use IPs. So that's why now you can see layer 3 IP header source IP 192.168.2, which was coming from here, heading to where? 192.168.1.1. It is using what? The ICMP message, because we are sending ping packets, which has type 8. This is the code of this to represent. So it has received this one. Now it is ready to reply back. And reply is also, as you know, you can see, it will be a flip. Okay. Now source IP is 1.1.1 and destination is 1.2, because now it is preparing itself to send back. So what will happen? Now it will go again back, because we are sending ping, and we know clearly that ping has request and the reply. So this is the reply. And it hit the switch. Now you will see, we know that switches have nothing to do with the switch, this layer 3. It has only to do with layer 2 and physical interfaces. So we will continue, and finally it is reached and now it will give me information. See, I'm successful. So I have one-to-one communication going on with each other. But now, if you want to remove these filters, you just need to click this arrow button and just delete everything, and it's gone. But now we are still hitting on a simulation tab. We need to go into the real time. So now we are back. So this was the first step. We know that we have the reachability. Okay. Now we want to configure. If I show you, show VLAN brief. This is the command to see the VLANs. And you remember from your test out labs and the switching module we talked about earlier, means initially every port belongs to VLAN 1. So whatever the communication is happening, by default, it is using VLAN 1. Now, the next step is I'm going to change this one to VLAN, let's say 150, and this one also into VLAN 150. Now let's see what happens now and how you can change to VLAN 50. First, you will need to create the VLANs on the same switch, which I'm going to do. Configure terminal mode, you will go into configuration mode because this is the configuration you are going to perform, and do one VLAN 150, which is very simple. That's it. You created one separate broadcast VLAN 50, but right now you haven't assigned any port to this VLAN 50. If I show you VLAN brief, as you can see, one VLAN 150 is created. Before, this was not there. It is active, but still no member from these ports has been assigned to this VLAN 150. Now I'm going to assign. You need to go into configuration mode. You need to go into the particular interface that you want to assign to, which is fast Ethernet 0/2. So to reach to that interface, you need to type this command, interface fast Ethernet 0/2. And if you want to see how many interfaces you have in this switch, this is a command, show IP interface weight. So it is telling me I have all the way from 0/1 to 0/24. These are my fast Ethernet interfaces. And then I have 2 gigabit Ethernet ports as well. And these are all currently down, except from these one, fast Ethernet 0/1 or 2. As you can see, this is up and up. And the reason is because we are connected with that one. 0/1 is connected here and 0/2 is connected here. So that's the reason it's up. Now let's assign VLAN 50 to that port. I'll just drag and drop some here to get some space. Now I'm currently on this switch. Okay, I need to go into interface, which is fast Ethernet 0/2. And now I'm going to make this host a member of VLAN 50. So the command is switch port access. If you are unclear about this command, what you can do, you can type switch port and then hit question mark. Further, it will dig deep. What you can do access, mode, negotiation, these things. But I'm concerned with this one. Switch port access. Now it is saying which VLAN you want to give to this interface. VLAN, and now it's 124094. So these are the total numbers of VLANs we can assign. But we know that we have already configured VLAN 150. So this is, we want to assign VLAN 150. And you will see, the link activity as well as soon as I will hit the enter. Because now it again going to go through spanning tree process. And because we changed the VLAN 1 information to 150, so that is going through the process of listening, learning, forwarding again. So this is just initiating. To confirm what port has been assigned, what VLAN has been assigned to this interface, you can check show interface, show VLAN brief. And now we can clearly see fast Ethernet 2 has been assigned to VLAN 150, and VLAN 2 is not any more member of VLAN 1. So now the situation is, this has become the member of 150. And this one is still the default VLAN 1. So my question is, Crystal, what do you gonna say about pinging? Can I ping that device? If I go ping 192.168.1.1, will I be able to ping that device?
I don't think so.
What is the reason?
They are not in the same VLAN.
Exactly. Now, just consider it like I have changed the subnet.
Yeah.
Okay, if I click, now you will see the ping is dying. It will not reach. So let's do it with the packet tracer now. If you want to clear, show all, click on this one. Now it has been cleared. Go to the edit, go to the ICMP, and we'll see where ICMP will stop. Okay, that's it. And select this one packet, and now I want to ping ICMP. So let's go here. Next, it is not proceeding. What is the reason? I want to identify. If you just click on this packet, as you can see, it is not leaving out this interface. Why? Because we have changed the VLAN information, the tagging. If you want to dig deep further, just click on inbound PDU details. Sorry. This is IP packet. We are not concerned about this one because we have nothing to do with IP right now. We know if our layer 2 is down, layer 3, layer 4, layer 5, these are useless. So at layer 2, which is Ethernet, what is going on? As we can see, we have source MAC, we have destination MAC. These are information are good. Then what is the odd thing that is making us not to reach that the other end? That thing has to do with the tagging, 802.1 Q tagging. And Krista, can you tell me what is this thing?
This is the trunking protocol.
Very good, very good. This is trunking protocol. This is a piece of the puzzle that we are missing in that. Now you can tell me what is the solution, Krista?
Yes, we have to assign the PC in a VLAN, in the same VLAN.
Okay, let's assign that one. I will follow you. First of all, clear these. We will go into that switch.
Yeah.
enable mode, configure terminal, VLAN 150. Okay, this is the VLAN we are assigning. Now we need to go into fast Ethernet 0/1 because we know we have to make this member of VLAN 150. Switch port access VLAN 150. To verify that, show VLAN brief, and now we can see whether it has become the member of that one or not. And now we can see, yep. Okay.
Yes.
Okay, that's fine. Just save this configuration. Either you can do type WR or
copy run start.
Copy running configuration, startup configuration. That's it. Make a good habit of saving the configuration before switching off the device. Otherwise, you will lose the configuration. And if you remember, we talked about the RAM. This all information, whatever you are doing configuration, it is stored on RAM unless until you will run WR command or copy run command to save it to NVRAM. Okay, so let's this activity link go into the spanning tree modes, and once it turns green, I will try to ping again. That is the reason it takes a lot of time, because it uses STP old protocol, which is IEEE. And we'll talk about, RSTP in a CCNA. This thing will be, processed very fast when we'll use RSTP.
So
it's
I have a question.
Yep. Go ahead.
I know that if it was one switch, we have to assign the interfaces to the VLAN, but like it's two switches. Don't we have to configure something on the uplink?
Good point. I was about to go there, but let's go through this step. Okay. Very good. So Gertrude, you have very good understanding about what we are doing. So I think there is a glitch. Okay. Let's ping this one. Can we ping? Now the situation is this one is a part of 150.
Yes.
VLAN 150, and this is also part of 150. Now they are both in the same domain.
Yeah.
Can we ping?
No.
Why? Okay, I think it's stuck. Why? Because I enabled this one. Just a minute. I need to go into real time. Sorry for that. Just a minute. So you need to click on real time, okay? Not simulation. Just click real time. So you have this. Still stuck there. Okay. Anyhow, let's go ping. Yep, it is not pinging. Why?
Because we didn't configure the trunk.
Okay, and why we need trunk?
For the tag VLAN on the frame to be able to go through the link to reach the other switch.
Okay, that's fine. You're pretty right. If I try to ping now, it has turned into green, and still you can see we do not have reachability. Now let's take the help of packet tracer. Sorry, not packet tracer, simulation. And clear these filters. Edit the filters. Click on the ICMP because we are interested in ICMP packets. Now let's see what happens where for this packet reach. And select this one. We are sourcing from here and going to this destination. Now click on this one. We have reached this router happily. Now click next one, and we are stuck. Now go into the packet again. And it is going to give me a nitty-gritty detail what happened here. Go into inbound. Still, we are stuck. Why? We cannot see any information regarding 802.1q, which is trunk. And we are, pretty much know that VLANs has to go across trunk links. This frame has no any information about this trunking protocol. It has source MAC, destination MAC. This is type, which is representing Ethernet. This is frame check sequence, if any issues with the frame. And this is the data. That's it. So that is the main issue. And this is the troubleshooting, area as well. That is why we use Wireshark to troubleshoot what is happening in the packet. So the remedy is, or the solution is, let's delete this one and remove this filter, and just I'll clear this one. So the solution is creating this as a trunk link. And how we're gonna make trunks? Very simple. Just click on the switch. Go into the interface, this interface, and tell him that you are trunk. So go into global configuration interface path. It has this one switch port. Now we don't need to go into access. Access is for only VLANs. We want to make it trunk. As you can see, set trunking mode. Switch port mode and trunk, and hit enter. Now you will see again it will go through STP process. So since we are here, I'll just save the configuration, and this is enough from one side. If we make it trunk, this is enough to make the trunk with this one, because this is already participating and passionately looking for to become a trunk, because this is crossover cable. But it is a very good practice to hard code the trunk on both sides. So we'll go into that switch, past Ethernet 0/2, and make it switch port mode trunk here as well, and save the configuration. For the verification purpose, the command is show interface trunk. Very simple. Now you will see it is saying my port fast Ethernet 0/1, which is this one, is the mode on. Means I hard code trunk there, that please become a trunk. The encapsulation that is it is using 802.1q. There was another flavor which is ISL owned by Cisco, but they are phasing it out because it is using kind of encapsulation and it doesn't understand the concept of native VLAN. Here is the concept of native VLAN and the status is trunking. So currently the VLANs which can go across this link are 1 all the way to 1005 through this interface. But the allowed VLANs are, which are basically configured, which is one by default, another one VLAN 150 which I configured. Okay. So Basically, it is telling me that only these two are capable to go through this. Actually can go all these one, but since these are configured, so these are currently going through this trunk link. And it is very slow. Really, this Cisco, they need to work on that they need to process these fast, but still, you know, they are taking a lot of time.
Mr. Cameron, you are still on simulation?
Sorry?
Are you still on the simulation tab?
Yeah, real time, exactly. A simulation tab, you know, why if I click simulation tab, and if I come on to this device, you will see a beautiful thing here. If I ping 192.168.1.1, if the simulation is on, just a minute, because I disabled the filters. If I add filter, let's say ICMP, and you know, I just didn't select this one from this one to this one. I just directly went into my PC, and if I type, for example, ping this one, now it's stuck here, unless until I will hit this one. Okay, so this is the use of this simulation as well. Either you can define source and destination, or just enable the simulation process and just ping to the destination. Now you are directing this packet where to go. So let's delete this one. I hope you get the idea and clear these filters as well. So everything is running right now. So what is your sixth sense saying, Crystal, whether we will able to ping this one or no?
Yes, you will be able to ping.
Okay, that's fine. It's stuck, but it should ping, by the way, because we have created trunk links. We have enabled 150. So let's verify once again. Go to the switch and let's see first. Show VLAN brief whether we have 150, and it is allocated to fast Ethernet 0/2. That's right. And show interface trunk whether we have trunk created or no. Okay, 150 is allowed to go to this. Now let's add on to this switch for the verification purpose. Let's see whether we have configured the mirror thing there. So show VLAN brief first of all. As we can see, fast Ethernet 0/1 is assigned to VLAN 50, and show interface trunk. Fast Ethernet 02 is enabled and it is trunking. So for me, there is no any issues. And let's check the IP as well, whether we have 1.1 and 1.2. Okay, so let's use the packet trace, the simulations to demonstrate what is the issue we are facing if we have issues. So let's enable ICMP. The filter is enabled. Now we want to send packet. Now it reach here. As we can see, it is green. Now it is proceeding. And we have the reachability. Now it will come back. And if this is tick mark, it means it has successful. But you know, one thing very nice there, I will show you again. Just remove this simulation from real time, and then again use the filter ICMP, and just source from here to here. Okay, and click here and click here. Now go into the detail of this one packet. So select the inbound video details to take a look. Now see the packet. Before it was Ethernet without 802.1q. Now we have the tunneling, or the trunking is going on. And if you remember in the last module, I talked about it will add few things. These are the things: TPID and TCI. This is basically the protocol ID representing 802.1q tunnel. I'm already not tunnel 802.1q trunking protocol, but you know, in your some professional, they also called it tunneling protocol because it is creating kind of tunnel, you know. Then this one, TCI, is tag identifier. If somebody give you this packet and ask you, can you tell me the VLAN ID? What you can do? Open the calculator, and I will share the calculator as well.
We were able to see it before you.
Ah, really? That's fine.
Yeah.
That's fine.
Yeah, we can see it.
Okay, you need to go into this programmer mode where you can see hexadecimal off. Okay, then just copy this information, copy this one, this TCI, paste it here. Oh, sorry, you need to select hex because this is hexa information, and paste it here, and you can see what is it written, decimal 150. Why, Christian?
I was saying the VLAN ID.
Yes, you're right. This is the VLAN ID. It's correlating with this hexa information. So you see the power of packet tracer?
Yes. Yes, indeed.
Further, if you want to go in detail, you can see this is ICMP packet. This is what I am sending. It has type 08, and 08 is ICMP's identification, just like this one. This one. This is the identification of your 802.1q. And this is the identification of your Ethernet. I think this is enough. This one until here. Okay. So we have reached, we have the solution until here. Now we are going to connect the router as well. Select the router. I usually prefer 2811. And as per our topology, yep, I need to connect this router with this one. So select any cable and connect like this. And let's assign the IP to this one as well under the same subnet. Let's make it 192.168.1.100. So at the switch point of view, you have to do nothing, just switch, just up this port. How? Go into configure mode, interface fast Ethernet 0/3, because this is what is connected with the router, and say no shut. That's it. No shut means initially my this interface was shut. I want to make it alive with the help of no shut command. But still you can see it is red because other end is down. So just write this configuration, close this one, go into this one. Go into the CLI. As you remember, we talked about, because it didn't find the configuration, so that's why it went into this wizard dialog, wizard. And wizard is nothing that they will walk you through some steps so you can, provision your this router, but which we don't want, because we know how to use console. So we will type no, hit enter, go into global configuration mode, interface, fast Ethernet 0/0, and assign the IP 192.168.1.100.255.255.255.0, and do a no shut. Now you can see these links around. So here comes the question, Crystal. Now I want to ping from this device. We know that using trunk link, I can reach this thing. Okay. But now I want to ping my default gateway, this one, which is nothing, just remember it just like a host machine, which is having this IP, just like this one. And I want to ping this one. Will I be able to ping this one?
Yes, because it's the same. It's the same subnet.
Okay, let's see. Nope.
Okay.
It is dying. Any idea, reason?
I wanted to ask why you didn't assign an IP to the FA03.
I didn't assign any IP to this one.
Yes.
Because this is just normal switch port. It is just forwarding whatever the information is coming, it's just spitting it out. That's it. Okay. I don't need to put IP. Why do I need to IP? Because routers have to do with IP things, not switches.
Okay.
But this is very good question, by the way. Okay, any idea, or I will proceed with the.
Oh, yes, we are in a VLAN configuration.
Very well.
I was still thinking that it was a default VLAN.
Very well.
Yeah.
Very well. So you need to go into
the switch
03, switch port, access VLAN, what? 50.
Yeah.
And do it no shut once again.
So.
And now you will see. Now tell me, will it be able to ping?
Yes.
Okay. Let's try. It takes so long. Meanwhile, we are here. I just want to give you another information. If you go into physical, you can see this router has these two fast Ethernet modules. But what in case if you want like further 8 to 10 modules? So what you can do, you can go into these fast Ethernet modules, and you just can drag and drop into this area to get more, ports. Okay, but for that you need to switch it off.
Yeah.
Okay, let's go and try ping. Yes.
Yes.
You were right. See how piece by piece we are going.
Yeah.
So we are able to connect our default gateway. That is the reason, because why I'm saying always default gateway. Now it has the connectivity with the ISP. So since we are here, it is good habit, go into IP configuration and assign IP 192.168.1.100, which is my default gateway, this one.
Yep.
Similarly, this one, 192.168.1.100. And we know why we need default gateway. When we have to connect to the ISP, okay, we need a default gateway, first of all. That will help us to resolve and to reach these public IPs. If you want to talk locally, these devices are intelligent enough that they have idea that this locally connected, these devices are locally connected. But if you ping like jobskillshare.org, which is residing on public IP, let's say 67.65 something, no longest match, by the way. Okay, you can take the same idea. No longest match. So where it is going to go to the default gateway, which is this one. So this one will resolve this one. Okay, so far so good.
So far so good.
Yep. Okay, let's add the ISP router as well. Let's pick this one. These are ISR routers. And let's very quickly connect this with this one. Now you are going to get the idea of how ISP works. So just change the name of ISP. And I'm gonna use IP something like public, so you have better idea. Like use it like 160. No, let's make it 99.99.99.x. Something different for these, because they want to communicate with each other. So they must have one IP in between. So let's very quickly go into this router. CLI, they know, enable configuration mode, interface, gig 0/0/0, and assign IP address 99.99.99.99 with, let's say, this mask. Okay, and do it no shut. So copy this one and I can paste it here, so I have better idea. These are my ISP. And if you have gone through DHCP, that is very good. If no, just ignore these things and what I'm gonna do. But if you want to move along, I will appreciate. Let's change the host name to ISP, so you will have better idea what router we are at. Now I am going to create the DHCP for this pool 99. How are we gonna do IP DHCP pool? We are going to assign the pool like our host pool. You are going to give name, and then you will give the same network from this range. Okay, so 99.99.99.0 with that subnet mask 255.255.255.0. And since we are here, we have other options as well. Like we can give the DNS server information from here. DNS server, let's make it 4.2.2.2. And default router, which is nothing but the default gateway. Means when this host will get the IP address from this one dynamically, it will know where to go. So this default gateway is for this one, not for this router. Okay, just get the idea. If you don't get, no problem. This is just for my lab purpose. I'm going to give the default router to this my device, same device, 99.99.90. Sorry. And that's it. If you want to verify show IP DHCP pool, I can see it is handing over these public IPs from these range. Now we need to, now you know, I told you public IP that router has assigned for you, you don't have to configure. So how you gonna get that? You're going to get that dynamically. To get that dynamically on your router, what you can do, go into your this router and name it, first of all, customer edge underscore router. Oh, sorry, host name, customer edge underscore router. So you have better idea that this is at your end. This is just like access point. So just for, sake of clarity, I'm just giving it access point. On my fast Ethernet 0/1, I want to access this IP dynamically. Configure terminal, internet fast Ethernet 0/1. This time I'm going to provide IP address, but what? To DHCP. Okay.
Okay.
IP address, DHCP, and hit enter and say no check. That's it. As you can see, the IP address has been assigned. If you want to verify show IP interface brief, you can see this is your heading to your public, your ISP, and the method is DHCP. It is up and up.
And if it was,
on the other hand,
and if it was like, not DHCP, like let's say we don't have multiple IP addresses, is it the best practice to put the static, right, on that interface, because you have that one IP address, that it's not going to change.
Okay. Yep. You can type, like, if you want don't want that DHCP, just you can go same interface, IP address, and if they will basically they will give you this IP.
Yeah. And this is a good, coming back to that one point, remember we were talking about, Christelle, that how does it work from the ISP end, and this is actually what's happening right now. This is where things are getting configured. Oh, we got an IP address, we put it on that F0/1 now, and now we're going to move on to other settings inside our network. After this, we don't care about what ISP is doing, because it's running, it has its own setup going on from their side. They may give you some kind of tools to check their connections, whatever it is, right? Here, now you're going back into your normal network and trying to get out of it. And that's what's happening right now.
Exactly. And you can see I have manually defined, but we prefer dynamically, because when we do dynamically, it comes with some other things like default gateway. Automatically, it will assign my default gateway, which I mentioned in my DHCP in ISP. So I will show you how. If I do show IP route, which is showing me my routing tables, and as you can see, the gateway of last resort, which is nothing but it is talking about this ISP, and it has no any information. But if I go the same interface, which is this one, which is heading toward the ISP, and if I say IP address DHCP, and just good habit is shut it down, no shut, so you can get the IP. Now you can see now it received 99.2 because I assigned statically.
And for new guys, if you're watching, I'm sure Kamran is typing very fast. So some people may, it's too fast, so slow it down.
No, actually, this is not the part of,
Yeah. And so that's why I want to tell people that because we're moving into certain explanations over here. So if you still are interested in just capturing these commands, pause this video, get back.
Exactly.
We can move on.
Actually, this has become my habit to go very fast. So it is like autopilot right now. So if you think that you have some confusion, you can stop me. So now this, if I do show IP route, now you will see the gateway of last resort is automatically configured. And another thing, that static route is also there. This is the reason logic behind DHCP, why they are giving you using DHCP. And if they are giving you a DHCP public IP addresses, and the whole idea behind that, another is, this will not be same the next day when you will come, maybe. Not this one. this configured, which is 99.99.2 on this interface. Maybe after 1 week when you will come, it will be changed to something else like 66, 55, something like that. So that is a good practice to keep it on a DHCP unless until you have very good documentation and you have given this these all things from the ISP, and they have directed everything to you that you have to use this by this way. Okay, so at this point, I'm gonna save this configuration. If I try to ping my ISP 99.99.99.99, as you can see, we have a success here. So it means I can reach because it is directly connected. So let's see the situation on these devices now. We know at this point, we know that it has a reachability all the way to this default gateway. And the default gateway knows how to reach this one. So what is your sixth sense says, will it be able to reach this ISP public IP? Any guesses?
We are in a VLAN configuration. I think no.
Okay. Crystal, forget about VLAN. VLAN only locally significant. VLAN story ends here.
Okay.
And we know that with the help of VLAN, we are able to reach. Now we have another story, which is the story of routing.
Yes.
And I told you that VLANs only works in a switching environment. It has nothing to do with routers. So, okay, no problem. And if you had this doubt, I just cleared it. Now I think you have better idea. So at this time, what you say that whether we will be able to reach or not?
From the definition of the router is able to communicate, I think it's gonna pass, the ping gonna pass.
That's great. Okay. Yes, you're right. So let's try first. First try my default gateway.
Yes.
So it means I have reachability all the way to my default gateway. And I also remember, if we are not wrong, under desktop, I have assigned default gateway as well. Means if it is something else, you need to go into default gateway. Go command prompt, ping. First, I will try to ping this interface, which is what, 99.2. So let's see whether I were able to ping or no. Yep, we have reachability. Why? Because this is directly connected. Let's see. Let's move one step further and try this one.
No.
It is time.
That's where 90% of the people, when they do labs, this is where they are stuck. 90%.
Yeah.
I love these labs, to be honest. You're doing a great job, by the way. And you are kind of separating it out because this is where people are. And if you look at FA0/1, clearly it's still connected to that network. So it knows it can reach there. So you know now through the VLANs, that's just internal part, but VLAN to VLAN, you still needed to know what? Trunking. And then through that, you went through all the way to this router. And then because of that router has this interface connected, it was able to do that. But now for that interface to go out of our network to go somewhere external, right?
Yep.
It's having a problem right now. So this piece is what we are trying to learn right now. What is this? So let's just find out.
So, Krista, what you suggest? What is the problem?
I think we need to configure a route.
Route for what?
For go to the other router, to the ISP router.
Okay, I'm going to give you a hint.
Okay.
These are our local LAN IPs. They want to communicate with what service? This is our public IP.
Oh yeah, we need NAT. Sorry,
Exactly,
I forgot about
exactly.
NAT.
No problem, no problem. This is our segregation point. And this router has no idea when this looking for 99, 99, 99. When this router, basically what is happening? It has workaround, by the way, but I don't want to make you puzzle here. The problem is this router has no idea about what this thing is. This is LAN. It cannot communicate with this public IP. These are RFC 1918, which are not routable. So that is the reason we provide solution as a NAT here. And we have discussed that NAT what will do, it will translate your this local IP into public IP somehow, excuse me, to communicate with the service provider. Okay, so let's quickly create that as well. This is the last piece of our puzzle. If NATing is, if you feel it is like difficult, just, now I think this is being recorded and you can just move along one by one. So first thing first, we need to define our router. This is my inside and this is my outside. Okay. Because the router is not intelligent enough. You have to tell him that this is going to be your inside network. This one, fastest and user. And this is going to be your outside interface. IP NAT outside. This is the first thing we have to do. Now router is intelligent. It has information that this is my local and this is my public. Another step which you haven't done this access list, we have to mention this our router that this traffic is coming from which IP, which subnet basically. So this is beyond your this session, but I'm just adding it for our reference purpose in the future when we'll talk about, you have idea. So we are going to create access list, which is saying what? Let's pick one. This is just for identification. I want to permit this traffic, which should match what? This subnet 192.168.1.0. This whole subnet I want to match. I can be more specific, like 1.1. In kind of, if we are doing static mapping, we will do this one-to-one. And in static mapping, we have to go one by one. But I'm saying that you need to permit this whole IP subnet range.
Yeah, I like that you're mentioning that, because I feel like we should connect it with those slides, those 3: static, dynamic, and PAT.
Yep. Yeah, exactly.
It's good that you mentioned that.
And this wildcards, it's nothing, just like inverse mask we talked about, and Crystal answered it very correctly. So inverse will be the opposite of the mask. And that's it. This is just one command. Why we need? Because in a NAT, we need to provide this command just to let this router know this traffic is coming from which subnet. We could have, multiple subnets. Router is blind totally. Router has only idea about this is inside, this is outside. He has no idea what kind of traffic or packet is going to hit. So we just defining here in a single line. Now here is the command I'm gonna do for NAT IP. And we need to find the NAT, and where we have NAT. I'm on a NAT from where to where? Of course, from inside to outside. So I'll select inside, because inside I have mentioned on this interface port, fast return 0. My source is what? Just I created the list. Remember access list, this one? This is my source. So the list is, and I have to assign the number which is assigned to SCR. Where it is hitting or where it is going? It is going fast Ethernet 0/1. So interface fast Ethernet 0/1 overload. You remember we talked about PAT, port address translation. This is another name of that, overload. This is the name of PAT, sorry. Port address translation. So whatever the traffic it is hitting here, it will assign different kind of port number to that, to identification purposes. Because the same computer can generate multiple sessions from the same source and going to the same destination. Let's say we have like a Google server. We know this host machine is going to the Google server from the same IP, public IP, but with different session. Maybe the Google has some different multiple session coming from the source to the same Google device. You remember in that NetStat how it identifies using the port numbers. So this is the same concept here. We are going to overload. So this is the basic command. IP NAT inside. You want to inside from which source it is coming. The list I mentioned here, this access list, which is on top of that. And then which interface it will leave out, 0/1, but do it PAT and hit enter. That's it. Save it. For verification, do show IP NAT translation. Currently, because I'm not doing anything, so that's it's empty. For now, this time try. Let's see, and I'm hopeful that it will work, because there is no any kind of issues. And do ping 99. So it is pinging. And if you want to verify this one, before it was nothing, because the ping has ICMP 4 requests and 4 replies. So these are the 4 ICMP. As you can see, the ICMP. So this is the by the way, the command show IP NAT translation. It is gonna show me in this router how this router is going to translate my this inside, and we know it is request is coming from 1.2 computer, but it is gonna translate with what? This outside local. And you can see it is assigning different ports to that.
So for my tip, I want to remember that, Christelle, if I forgot, let me know that to share the video with you guys, because this is, I have done this on a real network. So now when you see this, you can clearly understand what's going on. And then you see the real network example, because I haven't explained this stuff, then it will make a lot of sense with you. Once you watch this, once you watch my video and you got a lot of explanations now, you saw a practical example of this, how it works from all the way from story A, local everything, trunking, and then story B from needing a NAT to go out. Everything will make sense then. But of course, you guys have to still do a little bit more research on understanding if you want to learn more in deep, but things will come in future too in CCNA as well, right?
Yeah, yeah, exactly.
For now, I think that's for good enough practical things you guys can do to really understand this flow. To be honest, this is actually a small, not even small, even a medium-sized network can use this type of, this is a whole solution right here, to be honest. Of course, it's a little more than that, but for a beginner, this is a pretty good way to understand the importance of router over here, because we're talking about routing over here. And you see how important it got because you couldn't get out of to the public then. And that's why you needed router then. And for that to happen, you need to tell your router what to do specifically, from which interface it has to be assigned, and then specifically have to tell it what to do to be able to get out from this local network.
Yeah. So one thing I just want to mention, until here, we didn't do any kind of routing. There is no routing involved. But from here, even we didn't use any routing protocols. You didn't ask me these questions. We didn't use routing protocols, but we're still able to reach this server ISP. Any guess what is the reason? NAT is doing netting, but still how on earth this computer is gonna reach this one? Crystal, if you can answer.
Because it's one hub, it's directly connect one truss.
Okay, but I can configure some other routes and still it will be able to reach this one, which is even not on the same subnet, even which is not directly connected, which is connected somewhere else. Any guess?
No.
Because we are using routing kind of static. This is also a routing.
Oh. This is the default.
This is static route. Default static route. And if you remember, we discussed about the believability 0.
Yeah.
Because this is like directly connected. So it is always going to prefer this one. Okay, so your lab ends here, this one. I have further, I think this Danish will suggest, shall I move on to this IPv4 or this RIP? Although this is not the part of this one.
No, I think we need to add this to a second.
Because this is too much, yeah.
Yeah. We need because it's the RIP is a different story. So let's just end it here because we decided we want to end things around 2:30, 2:35. So that's great. I think at this point, and we do want to continue with the labs, Kamran. So maybe next time we can just start something with the lab, like include these labs somehow, maybe in a different recorded sessions or something like that. Okay.
Okay.
And so what are you guys going to do after this? Christelle and I have you guys will go back to the test out modules. And now when you see the modules again, I'm sure things are going to really make more sense. And when you guys do these labs, it's just going to give you a little more fun type, because now you understand why and how it is going through, like this pinging, how does it work? How does it actually talk to each other? And consider to be like, I really like the way Kamran is using stories. Like he separated out 2 stories and then he says this is a private LAN story, and in LAN story we only touch trunking, we only touch this or this protocol, whatever it is. Like I like that when you separate that in story, so then you retain this information very clearly then. But again, without
Thank
practice, this is gonna go away. So if you don't practice it, you'll be like me. After a few years, you will not remember these things. So make sure you guys practice this, and especially with packet tracer, because at the end of the day, if you were to become an engineer, you will not be just deploying things on a rail systems without actually doing some kind of practice or knowing some kind of topology beforehand. So just do that, okay? Get more practical with that. So, Kamran, thank you so much. Crystal, do you have any questions before we end? Or Haifa, if you are still there, do you have any questions in text if you're there?
I don't have any question. I only have a comment. I wanted to say thank you to Mr. Cameron. He kept me focused from the beginning to the end. I didn't know. I would like to say bravo to him. And thank you for Danish too, to kind of help us. He have some questions that I didn't have, but it helps me to understand the routing.
Yeah, like I told Kamran that my question is going to be always like a beginner. Like I am going to put myself in the shoes where I see so many people have these gray area questions, like ISP connections. And that's why I even told Kamran in the beginning that we will not do this kind of like in a normal way of let's just get into a router and just start routing, because then there is so many gray questions remain and so many people look for it, right, Kamran? And then that takes so much stress to find these things out. So look, the best thing people can do after this is that if you're a part of this program, you have Discord now, you're going to watch it now. See, I asked questions, you asked questions, so many things have been cleared, right, because of these questions. So on top of these, if you have more questions on top of these videos, you simply ask that in the Discord, and we will be able to cover that as well then. Of course, certain questions will lead you back to some kind of videos and things like that, but at least we will cover some of it. So imagine after some time, we would have a pretty good bank of questions that will be already covered, and that just adds more value to your learning. It makes it very easy. And thank you, Christelle, for asking good questions, and you're in it. So just keep on doing it, and Haifa too. Just make sure you guys keep doing it. At some point, this is going to become like a normal thing for you, and you will just need to learn more advanced things after that. At the end, man, Kamran, I want to say that again. Your passion of teaching is so detailed, and you really want to teach this stuff. You can see it, you know.
Thank you so much, Danish. And I just want to add here, because I went through these pains. I know that's the reason. This topology, I just divided it into different parts. So piece by piece, this is how we're gonna learn, and you will have a better understanding and idea what is going on, instead of it's just like throw everything on top of that. You will be puzzled and you will say, oh, what is that?
Yeah, no, then what's the point? Because we have people come to us with CCNP certified, CCNA certified, and that's the reason, because they went through it so fast, and they went through the labs also, but most of the people just can't convert this into a practice, or into a real, okay, I got it now, I can do this, or I understand this, or I'm not going to be scared if I am given a project for a router, how to configure a router between two routers, or the small network, because that's what you're aiming for as a junior network engineer. Maybe you're looking for some projects with small companies. Maybe they're going to give you, let's say, a $2,000 project to just figure out a small company for this small client, and boom, you got something going for yourself, right?
Yep.
All right, so thank you so much. Let's meet week 5, and I will share this recording soon with you guys once it's done.
So thank you so much, everyone.
All right, everyone, have a great weekend. Take care.